This is the stream that helps you out with math homework, science homework, all sorts of fun stuff. If you're having trouble, let us help you out. You're in the right place. Stop doom scrolling. You don't need to go see the feet pics or the, what is it, the hot tub streams or whatever people are doing these days to just try to bait views. I don't know. I've always just been like, just help people and see what happens. And here, let me get the chat working for TikTok. Let's get the chat working for YouTube. For TikTok. Oh, I hear myself. Chat working for YouTube. For TikTok. I don't want to hear myself. Chat working for YouTube. For TikTok. I don't want to hear myself. Chat working for YouTube. For TikTok. I don't want to hear myself. Chat working for YouTube. Okay, one sec. I gotta figure out why I'm hearing myself. Trying to activate my chat. What's that, Saphira? Yeah, good to see you. Okay, one sec. Let me put my chat up. I don't know why I did that. Come on, Social Stream Ninja. Let's go. There you go. Let's activate that source. Great. Let's activate this source. I don't know why YouTube Live's not popping up yet. What the hell? There it is. Okay. And it's a short. Okay. So now YouTube's working. Great. Hi, Saphira. Good to see you. Foreign language, physics, electricity. I'm taking I'm taking a bio break. Yeah. Okay. One second. Let me make sure this is working. Welcome. YouTube. Good. Okay. YouTube works. And then Jeff loves physics. Let's make sure that works. Good. I want TikTok to work. I'm gonna try. I feel like sometimes it opens. I'm gonna try. Oh, see. Yeah, I need to. Yeah, mute the video in that source. Okay, that's cool. Good. Fine. Awesome. I think it's still working. Oh yeah, and then let's see if TikTok works. Welcome. TikTok. Tiki-talk. Oh, hell yeah.
Oh, yeah.
All right, nice. We're rocking and rolling. Okay. We got 4 different platforms on, and I got all my chat working all in one place. I'm so happy. Okay. All right, so the first question comes from Poison Mouse. And this is what looks like a circuits question. Determine a tensão aos terminais de RL do circuito para as situações. So I think I can kind of read this because I do speak Spanish and Italian, and I feel like Portuguese is just a blend of Spanish and Italian. So I think this determine tensão sounds like tension. Is that like potential? It says, okay, your Poison Mouse is oh, actually, sorry, let me do I wanted to do this one first. Okay. Sorry. Consider the circuit, determine the potential at point A when these switches are flipped, I guess is what. Oh, I see. So you're saying, for instance, this would be, one second, let me get the right colors I want for this. Okay, cool. So like, for instance, this would be 1, this would be 2, this would be 3, and this would be 4. Is that what we're saying for like the placement of the, like which switch we're going to? Yeah, that's correct. Okay, cool. All right. So this is, and it wants the potential at point A. Oh, interesting. So A is here. And I assume A is measured relative to ground, right? And let's see, the easiest path for A to go down to ground is through a 3.3 kilo ohm resistor. Okay, cool. So, okay. So this is 0 volts, right? Yo, what's up, Richard, dude? We're doing little circuits. Right, so the voltage at A, I think, is measured reference to this. Okay, cool. Interesting. So wait, what is the difference here? What is this? I know this is a diode. diodes only let voltage run in one direction, right? So, for instance, let's do the easy case of, because I don't know what the fuck this thing is, but if it was doing this, for instance, so like, let's get rid of this. If this was going across a diode here, right? And then there's also a 3.3 kilo ohm resistor here. So let's draw like what the simple circuit would be, right? So you would have, because I assume the voltage source here is eventually connected to ground somehow, right? You can't just have like voltage coming out of nowhere. Voltage has to have a reference. Zener diodes. Ooh, okay. Little circuits here. Okay, so if this is like 10 volts, and then I got, was it 3.3K pulling here, and then we're dropping across a resistor, sorry, a diode, which I think diodes drop how much? Like 1.7 volts? How much do diodes drop? Diodes drop voltage, right? I'm pretty sure they do. It says, can I help me on steps? Oh yeah, I totally can. So Lyric, if you want to get help with your stoichiometry question, there's a website down there. If you can go to that website, actualdiscord.com/submit, and that will enable you to submit a screenshot of your question, and then it gets added to the queue, and then I'll do it. Robbie is the first one with something in the queue today. Yes, they're normal diodes. Oh. So you don't consider the 0.7 volt drop? Oh, okay. Fine. So then this doesn't do shit. This is just a wire, right? Because here's how diodes work. Diodes only let current flow in one direction, right? So they let it go this way, but shouldn't let voltage go this way, unless I think you reverse bias it and you go, and like, you can force yourself across it if you really want to. Okay. And then we have here, this is position A, this 3.3 kilo ohm resistor, and then we're finally coming to ground, and I'm gonna assume ground is just right here. Okay, cool. So, yeah, how much voltage is being pulled on each one? Well, I feel like if you only have two resistors in series, right, and you're trying to figure out the voltage here, that's essentially the voltage across the second resistor. It should split the voltage, right? So things in series have the same current, but they have different cross station 2. I agree that technically diodes have voltage drops. I think in this, from the Portuguese we're talking about, Jack, I think we technically say that admita que os are ideal, and so they don't have a 0.7 volt drop. Right, this is just a voltage divider is all it is. Exactly, Peter. Yeah, didn't read that rule. Yeah, you right, brother. Thank you, dude. Okay, is this a correct answer? Is it just 5 volts? But okay. He says, why doesn't the diode do anything on this one? Well, diodes, also, wait, what is this? Why do I have a 5.1 volts here? Yeah. I am dropping a lot of frames right now, but give it... Twitch gets finicky, dude. It takes like a couple minutes, and then it finally figures out how to like send bandwidth, I think, because I see no frame drops on TikTok, and I think we're, oh, the bitrate's a little bit low on YouTube. All right, it'll figure itself out. It usually does. It's a Zener diode. Okay, let's look at what a Zener diode is. I need to go check that. One sec. Zener diode. Ah, they allow current to flow in both directions. Oh, interesting. Yes, I would think so, Peter. But I think actually what happens... Okay, this is a source then. So we have 5.1 volts here. So what? That sets this to be 5.1 volts, right? Yeah, you're good, Lyric. I see it, Lyric. I see that you uploaded it. Thank you. Okay. 5 volts is correct? Cool. Okay, I agree it's 5 volts. Again, because we're saying the diode is ideal, I don't think we mess with it. I'm a little confused what this does. I'm reading up on this, and they say this is called a clamp. This is always fucking hilarious, dude, in, like, electrical engineering, when we just start coming up with, like, wacky-ass names for things. Like, what do you mean this is a clamp? Like, I guess this fixes the voltage here to 5.1 volts. Which in that case, I think A would always read 5 volts, right? Because if you're measuring voltage on A, you always reference it to 0, to ground. And so you're measuring it reference to this, right? But there's no elements in between here, right? So in that case, if this is a 5.1 volt source, would you recap why for number 2 the diode doesn't do anything? Because you said it's an ideal diode. If it's an ideal diode, then it doesn't drop the 0.7 volts. All it does is regulate that current has to run in one direction. So it's just saying that, like, current has to run this way. I can't run back current. Which, okay, maybe that's interesting with the 5.1 volts. Because this 5.1 volts has a couple decisions, right? The voltage can either run this way or can run this way. But it's going to run towards whatever is less potential. Which in this case is here. This is higher potential for sure. I guess... Yeah. Yeah. No, I feel like it's just 5.1 volts the whole time then. If that's the clamp. My live is lagged out. Give it a sec. Give it a sec. It'll fix itself. It always does. There you go. Yeah, Twitch it's fixing itself. Oh, you don't know if I'm talking or not. Oh, I am talking. Oh, I'm talking. Yeah. Let me maybe, one sec. Let me stop streaming on Discord. Sorry, Robbie. Check out one of the streams. Just, Discord sometimes, like, takes all my bandwidth, which is annoying. I think that'll sort it. Okay. So, I think that's 5.1 volts is what happens there. It's just choppy? Okay. It should fix itself soon. This is a 3.3 volt source. So, but again, I feel like because this is 5.1... For numbers 4, the solution is 5 volts. It's good now? Cool. Thanks, Jack. Yeah. Sometimes I just have to shut off, like, one of the streams or something. It'll fix itself. It is, what is it, Wednesday? Yeah. People shouldn't be, like, using too much bandwidth on Wednesday. Okay. And for number 4, the solution is 5 volts as well. Oh, okay. Well, that kind of looks like the same as this one, right? This kind of looks the same. Again, I don't exactly understand what the Zener diode means. How's going the mathing? Yeah, this is a little bit of circuits we're doing. Okay, he says it's used in automotive electronic systems that have an inductive load, i.e. an injection system or ignition coils. They clump the voltage spike produced after switching off, say, a coil. So they're kind of like a capacitor then? Capacitors absorb, like, voltage spikes, I feel like. No? Yeah. It's Thursday here. Yeah. Exactly, yeah, they're kind of like capacitors. Okay. I think this thing sets it all to 5.1. All right, let's just like throw this in ChatGPT. I'm always curious, right? Let me throw this in ChatGPT, see what it says. This in English, please. I will admit, I know a decent amount of circuits, but we start getting to specific weird components like Zener diodes and I don't know. Like I can do inductors, capacitors, resistors all day. That's like a physics thing. But when we start talking about like clamps, like what the fuck is a clamp? Exactly. Not much happens on the future, really. Tell me, Safira, what's in store for me tomorrow? Yeah, so this says like Zener behavior, which again, I would need to kind of like look up like how Zener diodes work. It can't answer properly. It's trying. Okay, here we go. It says a Zener diode is a diode designed to exploit the Zener effect. Okay, like so. Okay, what does that mean? I just want to know like practically how this works. Yeah, it's a PN junction, whatever. Shunt regulators regulate the voltage across small circuits. That is reverse biased. A Zener diode conducts when the voltage reaches the reverse. Okay. Oh man. I see. Okay. So you have to get over the breakdown voltage in order to go through the load. Oh, okay. This is cool, actually. Wait one sec. Voltage. I assume this is AC then. That's the Zener voltage. I definitely do mechanics. Yeah. Yeah. Okay, let's check one quick question. Let me check real quickly what ChatGPT says on this. And then, yeah, I'm going to let me move on and do some actual things I can solve. This is a little A, it's in a different language. B, it's also like a little bit above my grade. I'm not an electrical engineer. I'm a physics professor. So electro engineering tends to be kind of weird. Okay. ChatGPT says it's 3.3 volts, 0 volts, 3.3 volts, and then wait, 0 on 2. Why is it 0 on 2? I don't agree with that. What? Is a clamp at, and also where is it getting 3.3 volts? No, the clamp is at 5. The clamp the clamp is 5.1. Oh, okay. Abdullah says no matter what current flows through it, it fixes the voltage to 5.1 volts. Oh, okay. So if this is always at 5.1 volts, right? Look at the Zener graph, you'll understand. Yeah, I think we were looking at this. Something like, what is it? This? Is this like the Zener graph you guys are talking about? It has to do with current. So it acts like a open circuit after a breakdown voltage, I think. Or, sorry, it acts like a short. I always want to say like open circuit's the same as a short, but they're two different things. Yeah. Okay, here we go. Yeah, okay. Okay, so in this case, it says it's always 5 volts. Right, and I agree with this. I think everything here is just a voltage device. Like, look. You have 3.3 kiloohms here, you have 3.3 kiloohms here, and you're measuring this with respect to ground. It's always smack dab in the middle of this. Unless I think you go past 3, right? Then where is it getting its voltage from? Right? That means there's no potential difference here. But then this is always this to 0. You can also always move things towards junctions. You can't just go over components. So how I would see this is Yeah. Yeah. I don't think it's a 3.3 volt clamp. I think it's a 5.1 volt here clamp. Okay. All right. Let me move on because I have a couple other questions I got asked real quick. But I appreciate the question, Poison Mouse. I'll let whoever else is like maybe an electrical engineer and wants to explain this, please do so in the chat. But it's good. It's a good. I always like learning. I like attempting things I've never done before. It's fun. Arc length of Viviana's curve from a sphere on an internal tangent cylinder. Oh man. Okay, I need a softball real quick. I need a little confidence booster. Let me do this one real quick. Before people start. People love to give me just absolutely ridiculously hard questions to solve. When I start seeing names of math people that I've never seen before, then I start getting a little weird. Yes, I do mechanics for sure. Here we go. Let me do this one real quick. And this is from Lyric. What's up, Lyric? Okay, it says photography film is coated in silver chloride. No, we have to do chemistry now. This is one of the products formed when silver nitrate reacts with sodium chloride. What mass of silver chloride can be made from? I'm going to assume this is 11.7 grams of sodium chloride. Okay. So sodium chloride is just NaCl, right? And then products when silver nitrate. Okay, so silver nitrate. Silver is Ag. And then nitrate is NO3. And I believe NO3... Is NO3 a 1 minus or 2 minus? NO3 is a 1 minus, but I'm pretty sure Ag is a 2 plus. So I think this is AgNO3 too. So if this is 2 plus and this is 1 minus, you always just switch the coefficients, okay? So this becomes Ag1, this becomes NO3 2. So Lyric, I think this is this. And then what you end up getting, silver nitrate, sodium chloride, and you get silver chloride. Okay, so you get AgCl. And again, I think this is AgCl2 because I believe. And then the question is like, where the fuck did the nitrate go? Maybe it's, and then what is it? Sodium nitrate. Do we get sodium nitrate as well? I'm gonna guess this gets produced, right? I think it's AgCl2. But I can also like Google this. What do we need? We need because these reactions are very common. So silver nitrate plus sodium chloride. I will balance it. Yes, I will balance. I just want to make sure I have the right structure first. Okay, here we go. Oh, it is nano. Okay, sweet. Look at this. Okay, awesome. So we came up with the right equation. I'm happy about that. Yep. AgNO3. Oh, they say it's AgNO3 Huh. Really? Ag is a 1 plus? I don't believe that. I guess so. I keep seeing this. Okay, fine. I mean, the reason why I say this is that we go to like the periodic table. Lyric says that's wrong. I agree, bro. Yeah, because if I look at the periodic table, Ag is like in the middle here, and these are always like either 2 plus or 3 plus. Very rarely are they 1 plus. But I don't know, man. Ag2 is right. I believe it, but if I keep seeing this on all these websites, I don't think all these websites are wrong. All these websites tend to say that Ag is a 1 plus. So, oh, Hitu says serpentine triangle. I believe Ag is actually 1 plus. Okay. I mean, this is also like a pretty reputable looking video, right? Yeah. Okay. So I think it is 1 plus. Fine. Okay, I mean, that makes our life easier, right? Because this is balanced. Look, because, like, nitrate, nitrate, sodium, sodium, silver, silver, chloride, chloride. You have one of each. Yeah? How do you know so much science? I teach a lot of science. Thanks for the follow, Dylan. Okay, so here what it says. It says how much silver chloride. So I'm going to say how many grams of silver chloride, so that's AgCl, can be made from 11.7 grams of sodium chloride. Okay. Anytime, lyric here, anytime you see two different compounds, okay? You see how I have, like, this is a different compound than this, right? That means I need to always work with moles, because then this is called, like, the mole ratio, which is basically, like, what the coefficients are in front. That allows us to like, go from a different compound, from NaCl to AgCl. I'm already in grams to grams, which is great, but I have two different things. So the first thing I have to do is I have to figure out how many grams are in NaCl, which, I don't know, it's probably 29 or something. Let's see, molar mass, NaCl. Dylan says, chemistry tutor here, Ag is actually +1 during certain situations. Oh, that's very cool, Dylan. Thank you. W, dude. Thank you. Yeah, because I was thinking Ag is always like a 2+, right? But you're saying that, like, during certain reactions, it's not. Okay, so this is going to be 58.44 grams of NaCl is equal to 1 mole of NaCl. And then we do 1 mole of NaCl is equal to 1 mole of AgCl. And then finally, we need to eventually get to grams of AgCl. So I'm going to say that 1 mole of AgCl. Molar mass of AgCl is, what's up, Issa? 143.32. Everything cancels, right? So I have grams of NaCl, grams of NaCl. This cancels with this. Then I have moles of NaCl, moles of NaCl. That cancels. Then we have moles of AgCl, moles of AgCl. And then that leaves us with grams of AgCl, which is what we were looking for. This is why stoichiometry is dope. It allows us to, like, find this stuff. Do I have any university cheat codes? Study. Studying's pretty dope. You should definitely study. Girl, don't attention classes. Girl, don't attention classes. What? Excuse me? What? Excuse me? What? Okay, let me get my calculator out real quick. I need my silver. Where's my gold calculator, though? What? I don't want no silver calculator. What's up, Femvox? Good to see you. I'm trying to get my calculator to work. Where's my calculator? Oh, man. Oh, there it is. Okay, I found it. I just have too many windows open. That's why. Okay, here. Let's fix this. So, Dylan says when silver loses its 5s electron, it forms a silver 1 ion. Ah, okay. We can look at that structure later, yeah. And then one sec. I need a... one sec. I need to edit my preferences real quick. Okay. So now pull the calculator out. And what we want to do here. Oh, if this wants to load. Oh, I know what I need to do. Sorry. I need to change this shortcut. Sorry. This needs to now be Shift K. Okay, there we go. Do you want to load today? Okay, there we go. Now there's the calculator. All right, so we multiply everything on the top Do I teach chemistry? I tutor it. I don't teach it like officially, but I definitely tutor it. Yeah, sure. I would love for you to explain. Yeah, let me get through this one real quick, and then you can explain it to me. So times 1 times 1 times 143.32. So that's the top. And then we multiply everything on the bottom. So 58.44 times 1 times 1 times 1. So that's just that. And then you do top divided by bottom. And that's going to get us 28.69. Okay, cool. So you should have 28.69 grams of AgCl. Okay, I think that's the answer. Lyric, let me know if that makes sense to you. I see my internet's like dropping some frames. I might start killing Twitch, honestly. Twitch is always messing up my frame rates. It's right. Nice. Good. Sick. Fox says, I draw the line at accounting as well. I agree.
Well done.
Okay, nice.
Well done.
Good question there. So let's take lyrics out. Oh, I need to, one sec. Let me log back into this. Oh, it does that. Okay, cool. Nice. Okay, so one quick, Abdullah's gonna answer this one that Poison Mouse had, and then let me do Justin's, and then I'll do the Viviani's curb, Robbie. I'm a bookkeeper that has some accounting subjects on my belt. Sick. Well, there you go. There's your person, dude. Help me in differential equations. I'm failing. If you're failing in DiffEq, submit a screenshot, and I'll do a DiffEq question for you and teach you. So Abdullah says 3.3 volts and the 5.1 volts is the Zener voltage. So that means when the voltage is that or greater, it allows current to flow through acting as a short circuit. Okay. So 3.3 and 5.1? I definitely tutor AP Physics C. Yeah. I do a lot of AP. I have a physics PhD, so like I do a lot of physics. Yeah. I've run review courses for AP Physics C too. Sick. Awesome. Thanks, dude. I'm glad the videos on projectile motion are helping you out. That's really great. Nice. I'm a lifesaver. Dope. Love that. Okay. So one sec here, Abdullah. Sorry, where's the 3.3 volts coming from? Are you saying if it's under 3.3 there's no current, but if it's over 5.1 there is? So when you did KVL, you found 5 volt as the resistors are equal voltage halved. But so it went through the 3.3 voltage Zener, but it didn't go through the 5.1 voltage. Oh, I see. Sorry, I see. But wait, that's if it was going through switch number 2. Did this Zener voltage matter then? I understand that this one, but I think how the question worked is they said if the switch here, sorry, I gotta like get the switch. If the switch here is like connected to all these different positions, I think is what they said. Hey man, no offense. I just like to understand the purpose of being able to learn these types of subjects. It's the same reason that you go to the gym and you lift weights, right? Do you lift weights because all your life you're going to be lifting weights? No. You lift weights because it makes you stronger, and then you can go do other things. So I think the purpose of learning a lot of these subjects is training your brain how to, like, learn subjects and solve problems. And it's challenging. And doing that makes other challenging things easier that may not be directly related. Okay. But I see this. Wait a sec. I want to see Abdullah's comments on this. Sorry, I gotta figure out where my chat is for you. Okay. Exactly. Okay, okay. Yeah. Do I need this if I'm considering making cybersecurity? No, you don't need to do this probably. I don't, well, maybe. I don't know. CS kind of does. Okay. I'm going to save your stuff here. But that makes sense, right? If you're going through switch number 2, you don't see the 3.3 voltage Zener. You do see the 5.1, right? Yeah. Okay, cool. Let me see. I have another question from Justin that came up. So again, if you're watching my stream right now and you have a question you want me to go through on the stream here live for free and teach you, you can do so by just going to this website that's linked down below there, theactualdiscord.com/submit. And then if you put in like a username so I know who you are, and then drop an image in and hit upload, it'll get sent to me and it gets added to the queue, and then I'll go through it. Also, if you want to figure out other times we stream, you can click on the streaming schedule button, and that'll show you all the different times on a nice Google Calendar that we stream free homework help, in case, I don't know, you got to go eat lunch or something. Sphere says, I'm a jack of all trades. I'm a pretty big jack of all trades, too. You have a zoology degree. Wow, that's sick. How long is the queue? Oh, another cool thing. So if you ever want to see the queue, you can type Q in... well, actually, you can see it. Wait one second. Actually, you can't see it. Let me do this. There you go. That's the queue. The queue right now is 3. But wait, I just did somebody's. Oh, no. Robbie just submitted another one. Robbie's submitting all these fun ones. He's like, come on, do my Viviani's curve, dog. Didn't I do this one, Robbie, for you, though, dude? The Viviani's curve? Pretty sure I did. So really only like 1 or 2, Becky, if you want. All right. Let me do this one for... this one is for Justin. Okay. So the integral in this exercise converges. Evaluate the integral without using a table. Ooh, that's kind of difficult. Fuck. I like this 25. This 25 makes me think of things, right? Because, I don't know. I see like 5 squared. And then... this and... oh, yeah, no, you're good. You're good, Robbie. But did I do that one for you, Robbie, yet? I think I've seen that question before. Also, let me know if it's, like, kind of solvable. Or if it's just a nightmare. So, x times x to the 1/2. That would be x to the 3/2. Nice. But then you have 25 here. So, you have 25x to the 1/2 plus x to the 3/2 on the bottom. I still don't think that, like, helps you out, though, right? Can you partial fractions this? We can try. I don't know what the rule is for, like, square roots of things, though. Yeah, so Jeff has a good point. If this was just, for instance, like blah, 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 and it was over like x plus, I don't know, like 3, like x minus 4, this can totally be done with partial fractions to be like a over x plus 3 plus b over x plus 4, x minus 4 or whatever. Yeah, this would be great. I would love to do this. And I guess I kind of see it. I just don't know. What's the partial fractions rule for square root of x? Oh, Sebas has something here. Oh, okay. Oh, is it? Oh, is it cubes? Is it really cubes? One sec. Okay, cool. All right, we'll take a look at it, Robbie. let me see. So Sebastian says that, okay, so if I distribute this in, right? So we have 25x to the 1/2 plus x to the 3/2. I agree that this is the same thing as x to the 1/2 to the 3rd. Oh, and then this is 25x to the 1/2. How does that help you, though? That's great, Sebastian. Okay. Oh, okay. Wait. How does this help me, though? Because this is still on the bottom. Or is there... Yeah, Poisson, if you want to submit a screenshot, there's a queue there. And I'll go through questions. I learned plasma physics. That's what I learned. All right. Okay. There's some trick here. Let's see. What if maybe like let's let x equal something. No. This is evaluating. They want us to evaluate. Okay, let's try this. Let's like let x equal to I don't know. Let's say like 25. I like the 25 here. Maybe like, but then I don't like this. Okay, wait. Let's say this is equal to 25u. Okay. Then dx is equal to 25 du, right? No, but then I have the square root of 25u. I don't like the square root. Okay, wait. Let's make this 25u squared. Because I really don't like the square root on the bottom. It's messing all my shit up. Yeah, no, Justin, let's try this. Okay, so I think this is like, then this is 50u du. This is very cool. Because then the square root of x is equal to 5u. Right? Yeah. U equals square root of x. Exactly. Yeah. Okay, so wait, watch what happens. Okay, so now my dx is 50u du on the top. 25 plus x becomes 25 1 plus u squared. Right? And then this becomes the square root of x is 5u. Ah, look at this.
Good job.
I think I see something here. Do I? Yeah. Oh, this is super cool. Watch. This cancels. 50 and 5 becomes 10. Yeah, we're basically forcing a u sub here. Okay. So then I have 10 over 25 integral of du 1 plus u squared. This is a known one, right? This is arctangent, I believe, right? So this is 2/5 arctangent of u, but then u is equal to the square root of x over 5. Right? So you get 2/5 arctan square root of x over 5. And then that's evaluated from 0 to infinity. Arctangent of infinity is just pi over 2, right? No, it's cool to watch. Yeah, no, I'm glad, Eden. Yeah, you'll learn something from this. Just, like, hang around. Okay, so this is 2/5. Arctangent of infinity is pi over 2. Arctangent of 0 is just 0. Oh, so the answer is just pi over 5? I think that's it. Oh, yeah, sometimes it does. Avery, if you want to submit a question, yeah, to all my people on TikTok who are saying, please go over this, please go over this. The best way for me to help you with a question is for you to find a screenshot of a question, like a student did here. And just submit it using the website down there. And then I'll go through it. I see Robbie, Justin, and Galactic Marrow, yeah. IB4N says it should be only square root of 5 inside the inverse, or nah. No. Because this integral right here, this is arctangent of u. But then from here, we said that x was equal to 25u squared. So if you move that under and then square root, you get u is equal to the square root of x over 5. Right answer? Nice. Fuck yeah, dude. Love it. Awesome. Thanks for the follow, Ronnie. That was a cool question. Okay, sick. I wish I could learn by osmosis and know the processes for all these questions. I mean, you are learning by osmosis. Learning by osmosis is real. If you just watch other questions get done, you'll learn something. It's even better if you do the questions, even if that means just copying down, you know, watching what's happening and doing it with a pen and paper. Your brain will learn it better. It's almost like a muscle memory thing. It's how I got through vector calc in undergraduate. I just started like handwriting solutions and eventually like absorbed the knowledge. What a cool channel. Thanks, man. Yeah, for sure. All right, let me see Robbie's question. We're gonna try this one, and then I do see yours, Galactic Marrow. Thank you. Viviani's curve. Oh, of course. Yeah, as a math major. Yeah, for sure, dude. It's an important one. Okay, here we go. First of all, what is Viviani's curve? Let's go look this up. Oh, okay. Viviani's curve is a space curvature giving the intersection of a radius and with a cylinder and I guess a sphere. Yes, Andrew, I did see yours. If it wants to load, one sec. Yeah, I see yours right there. Yeah. I see yours, Andrew. Yeah. Mathematical induction problem. That's fun. It is a sphere, right? I think it's a sphere. Or this is like Viviani's window. Is the window the same as the curve? Oh, it's a real analysis question. Okay. Solve for the sphere and the cylinder. Right, so this is going to be vector calculus. There's going to be parameterization, polar coordinates. Okay. This looks hard. Yeah, what math is this, Robbie? What is this? And then there's lateral area. Great. I love the limits. No, someone asked for Epsilon-delta. No. I fucking hate Epsilon-delta. I still don't understand Epsilon-delta. I've been teaching calculus for like 15 years. Okay. All right. Whose axis is parallel to the z-axis and tangent to the sphere at the origin while passing through the sphere's center. The intersection of these two surfaces is Viviani's curve. Compute the total arc length of this curve and express your answer in terms of the elliptic integral of the second kind. Oh, shit. Oh, that's gonna hurt. It's gonna really hurt. The fuck is... This is Calc 3 and real analysis jammed in 2 semesters? I believe it, dude. Yeah, no, this is not easy. Don't worry. This is not an easy question for sure. Okay. All right. I don't know what elliptic integrals are. But we'll figure it out. Okay. Let me draw like some... I need some pictures, dog, right? I can get the computer to do it for me, right? Yeah, we could. Okay. Whose axis is parallel and tangent to the sphere at the origin while passing through this... So... Oh, okay. Wait. So this tells me that the cylinder is off on the x-axis by r/2. Okay, so it's over here, and it has a radius of r/2. Okay, this is cool. Okay, I think I understand this a little bit. So this is the cylinder, per se? Like so, right? And then it's also... So here, this is the cylinder. But then it's also through a sphere of radius r. Okay, and the sphere goes out to there, basically. Yeah? I'm trying to draw it as best I can. Okay. And we want the intersection of these two things. I get it. It probably makes like some cute little like curvy thing. This is the part where I use AI to help me. Yeah, I'm totally going to use AI to help me on this one too. Okay. Let's see. So we do need to parameterize this at some point. And maybe the best way to do that is with R. Like try to parameterize what the radius is as a function of theta. Right? Because this thing is going to do some wacky... like whatever, right? As we go around. I mean, I use AI for sure. Yeah, no, I definitely use it. Okay. Okay. X squared plus Y squared. Oh, okay, wait one sec. I think we can simplify this now, right? Okay, let's try simplifying this. So, what's that going to be? That's going to be x squared minus 2rx over 2 plus r squared over 4 plus y squared is equal to r squared over 4. Yeah? So then this goes away, this goes away. So then I'm left with x squared plus y squared is equal to... Oh, wait, and there's a 2 on this one, too. Oh, it's just equal to rx. Okay. Shouldn't the cylinder go through the middle because it's r/2, not d/2? I don't think so. No. So, if you look at the equation of the cylinder, right? X squared plus y squared... If we just had x squared plus y squared... was equal to r squared, that would be in the center, right? But this tells me it shifts along the x-axis by r/2, and then the radius is now r/2. When do you learn Epsilon-delta? You learn that like the first couple weeks of calculus. It's like the limit definition kind of thing of derivatives and stuff. Recall that x equals r cosine theta, y equals r sine theta. Oh, nice. That is true. Okay, yes. So, in polar, right? X equals r cosine theta. Y equals r sine theta. So now we're left with r squared cosine squared theta plus r squared sine squared theta is equal to rx. And so cosine plus sine squared is just 1. That's why you got to remember trig. And so I just get that r squared is equal to big Rx. Right? Wait, but then x is equal to r cosine theta. Oh, okay, wait. R squared equals to r cosine theta. Assume r is not 0. That goes away. Sorry. So you get r is equal to big R cosine theta. Yeah? That's pretty dope. Yeah. Okay. Yeah, for sure. You can try. Yeah, try sending it. I'll try to do it for sure. Just add it to the queue. I guess the queue is 6 things now. I love cats. Andrew, yeah, a lot of people. We'll get to it. Okay. Okay. So now I need a parameterization of the intersection here, right? Because I mean, this just tells me x squared plus y squared plus z squared is equal to r squared, right? How do we parameterize the intersection of these two things? Let me see. Let me see what the other guy was doing on Stack Exchange. No, but no. But R refers to the R. So, Jeff, R refers to the position from here, right? This is R. So, what it's saying is that big R cosine theta is, yeah. I think that's all we've done here, right? Is just taken this and substituted in polar coordinates, which is now telling me that the radius of all points on this cylinder is just equal to cosine theta. Rho? Yeah. What's up, Zach? Zach, have you seen this before? Have you seen Viviani's curve? Just math people just like sticking random ass shapes on top of each other and like hoping something happens. I would use spherical, not polar, but I kind of like having just r theta. Right? Yeah, I'm thinking, right? So if we have x comma y comma z, the way to do this is to call this r cosine theta, call this r sine theta, and then what is z then? I guess we need phi in there, right? Yo, what's up, Jamarcus? R theta and z, yeah. Yeah, good to see you, Jamarcus. Yeah, no, it's been a while. Welcome. We're doing a pretty complex math question here. That's cylindrical, right? Yeah, but then what do I do for z then here? Because I can kind of follow how this is going to work. You have to take 6 semesters of calc? Wow, that's a lot of semesters of calc. Six semesters. Yeah, meow, dude. That's a lot. Sorry, I'm really excited. Yo, what's up, Maria? Oh, you're doing vectors. It makes sense. Good job. I'm glad that things finally make sense for you, Maria. Physics isn't all bad. Yeah. Okay, wait. Let's make these things intersect. Okay. So wait. I have this has to equal this, right? Okay. So, x squared plus y squared plus z squared is equal to big R squared. But then x squared plus y squared is also equal to rx, right? So rx plus z squared is equal to r squared. Oh, I think I see something here. Oh, maybe. So then x is equal to what's that gonna be? Or wait, no, sorry. Z squared equals r squared minus rx. Okay. So then x is equal to z squared over r minus r. Oh, this is so funny, though. Oh, okay. I think I've seen this. Dude, this is so... Dude, this logic is all over the fucking place, dude. Okay, but then x squared plus y squared is equal to rx. And then... So that means that y squared is equal to rx minus x squared. So then if you plug this back into this... This is, yeah, too much. Oh, okay, so he says z equals plus or minus r squared minus rx. Yeah, you're good, Maria. Good to see you. Okay. All right. I need to rely on some things. Okay. I need to... Cool. Yeah, I can help you with Maxwell's. Yeah, submit a screenshot. I need like the parameterization. This is nightmare level math. This is like real analysis. Which I'm probably gonna punt on this in like a minute or two just to give people time. It's a little above my pay grade. I don't really do real analysis. I don't know. This is becoming like a clusterfuck of things. Bless you, Robbie. Bless you, Robbie, you're having to take this. Because I mean, I'm close here. I like this because if I know r is equal to big R cosine theta, then this becomes r cosine squared theta. This becomes r cosine theta sine theta. So we almost have the radius of intersection just in terms of theta, right? Because big R is constant, and this is just... I'm just confused how to relate the Z intersection. No, physics is great. I love physics. AP Physics C? Yeah, no, you'll be okay. I teach a lot of AP Physics C. I can definitely help you with it. Because here's the beauty here, right? Then all I need to do, Robbie, is eventually just do the arc length integral, right? Which is just going to be 0 to 2 pi. And what's it? Square root of 1 plus r prime theta. D theta squared, right? Like, we're so close. Once you get to this is all easy mode. You're in optics and modern physics? Cool. Nice. Yeah, okay. I think the last step here is to get Z. I don't know how to get Z, but Robbie, if you can figure out how to get the Z parameterization for this in terms of theta, which I think is somewhere here, then all you need to do is this, and then you're done. Yeah, okay, cool. All right, nice. I appreciate the question. Good try, but let me move on, make sure I can help other people. Oh, square root of r squared plus r prime squared?
Well done!
Yeah.
Well done!
No, I think it's just... yeah. Oh, he has it? One sec. Maybe Zach has something. Oh, U Texas, dude. That's where I went to school. That's my alma mater, dude. That's my undergrad alma mater. Oh, sorry. All right, sorry. This is what it actually is. Sorry, my bad. Sorry, in polar, it's this. Brilliant. I do like brilliant. Yes, we do a lot of stuff with brilliant. Okay, sorry. So this is the actual arc length curve you need. Sorry. I was close. Just put an r squared here. And there you go. Yeah. But you need to figure this out. You need to figure out the last parameterization of this in order to do it. Yeah, camera physics. Yeah. I think you have to take all 3, usually, at some point in your life, no? Okay. I don't know why this is not loading. Okay, let me see Justin's question. Oh, we did Justin's, actually. No, we did Justin's. Okay. So... No, I didn't want to delete Galactic Marrow. God damn it, no. Okay, let's do this. This is Galactic Marrows. Here, Robbie, I'll also send you the screenshot of what I have so far on this. There you go. That's my attempt so far. Okay, let's see. This is Galactic Marrow's question. It says find the higher order derivative. This is not too bad. So if the third derivative is this, so they're asking for the fourth derivative. So, I mean, f4 of x is just equal to ddx of f3 of x, right? It's just the next derivative. These are sometimes weird to deal with, okay? But the way to always remember this is that if you want to write, you always want to try to write your variables as like to an exponent, like a single exponent. I don't care what the number is, right? So yeah, Jeff has it down. The way you do this, so let me do it in terms of colors so you can kind of like make sense of it. Okay, here we go. So if you ever have like x to the, what is it, 3, and then this is saying this is the fourth root of x to the 3. This is the same thing as x to the 3 over 4. Okay? So what you do is you figure out like whatever the root is, that's the bottom fraction, and then whatever the power is, that's the top fraction. Yeah, I mean, yeah, it could be, it's like telescope astronomy, I guess, or something, right? Yeah. Okay, so this is just going to be ddx of x to the 3/4, which we know for taking derivatives, right? You take whatever this is, you pull it down, and then you drop the exponent by 1. So this is going to end up equaling 3/4 x to the 3/4 minus 1. Okay, 3/4 minus 1. Uh-oh. I gotta, like, subtract fractions. We're going back to 5th grade, right? So 3/4 minus 1 is the same thing as 3/4 minus 4/4. And so that's going to get you negative 1/4. All right? Oh, yeah, so optics. I can try to help with optics. Some of that stuff gets weird, like diopters and whatever. Yeah, okay. This is technically the right answer, but usually your teacher gets upset because they don't like negative exponents. So then you have to go back and convert it, right? The first thing I'm going to do is anytime you see a negative exponent, that means flip it and then make it a positive exponent. And what I mean by flip is instead of being like x to the negative 1/4, this is going to be 1 over x to the positive 1/4, okay? Which is the same thing as just putting the 1/4 exponent on the x on the bottom. Yeah, all this stuff gets recorded. Yeah, it's all yeah, make sure, go like, subscribe, whatever, on my channel, and all of these live streams get uploaded directly to there. So then this is 3/4 times 1 over, and then this, right? So that's x to the 1 4th rooted, right? Remember, this is the root, this is the power. So you can just say this is equal to the 4th root of x. And so I guess maybe a cleaner way to write this is 3 over 4 4th root of x. And you're done. That's how you do that. This is intro calculus. So let me know, Galactic Marrow, if that made some sense to you and stuff.
Well done.
Rationalize the denominator. Do you really want me to rationalize this? My next, so if you ever want to figure out when my live streams are, again, this website, www.actualdiscord.com/submit. This is where people are uploading screenshots for me to go over. you can also click here on streaming schedule, and this will show you the times we're streaming. So I'll probably stream now for another like hour and a half, and then tomorrow's stream starts earlier than today's did. So you can go check out when we stream, and also Zach, who's also on our channel, awesome guy. Let me make sure I give Zach a shout out. Sorry, I forgot to give you a shout out. Thank you, Zach, by the way, for your. But he's on Twitch. If you want to watch him on Twitch, he does math help on Saturdays, and then I think I'm gonna start taking on Sundays as well. So next week I'll start doing Sunday, Monday, Tuesday, Wednesday, Thursday. Just because the school year's starting, it's getting busy, and I can tell like people need help. That made sense. Thank you. We're gonna do the chain rule next, and then okay, awesome. Yeah, if you ever want videos, I don't know if Galactic, if you found us. Oh, I'm glad you found us too, Cats. If you go to my channel, I have a pretty popular video on the chain rule. Just go to search here and just type in like chain rule, and here's like a video I have. This one has 112,000 views on it, which is crazy. But I do fun little quick tutorial videos, little shorts on like how to do the chain rule, how to do the different rules and stuff. So you can go check those out as well. Why does the chain rule work? Magic. I can do an example at some point, but yeah. Okay. Let me see. Next on the queue, I did Justin's. I don't know why it's marking. One sec. I did Justin's. Okay, so next is Andrew Phillips, who wants me to prove something with mathematical induction. And then I Love Cats, you got Epsilon-delta for me. Oh, man. I'm going to get wrecked by Epsilon-delta. Thank you, Andre. I appreciate it. W teacher. Hope everyone's having a nice Wednesday. Middle of the week. Weekend's coming up. Do you guys have anything fun that's happening over the weekend? I'm going to be DJing and playing cello, which will be fun at like a Burning Man thing. Oh, and also I have an interview with another streamer on Friday. But again, it's all on the calendar there if you want to find out what we're doing. Okay. Use mathematical induction to prove the following. For all n is greater than 1, prove that 1 squared plus 2 squared plus 3 squared plus n squared is equal to this. Oh, this is cool. N times n plus 1 times 2n plus 1 all over 6. So from the sum from n equals 1, or I should say, sorry, the sum of x equals 1 to n of n squared. No, sorry, x squared. I mess up my sigma notation all the time. Jeff says this should burn the rest of the session. Okay. This is all about like you have to like develop a base case, right? Isn't that what we have to do? So let's refresh like how you'd use mathematical induction. I need a refresher as well. Mathematical induction. Shub says, I still go back to your videos or my vertical asymptote and horizontal asymptotes when I forget which one is which. W, dude. Love that. Love that you still do that. Yeah. Yeah, okay. This is kind of like how we do it. Oh, it looks like someone had already done this. Well, let's see how this one works. How does... Yeah, you verify the result works for 1, and then you assume... And then you show that the result is true for the next, like, n plus 1. Yeah, here, I'm gonna, like, steal this guy's screenshot just because I like it. Yeah, base case K, proof for K. Yeah, okay. That's how you do it. Okay. So let's see. He's proving in this case that the arithmetic infinite sequence sum thing is just n times n plus 1 over 2. So you assume true, n equals k. And then show it's also true for n is equal to k plus 1. Oh. I think I see this. And then if it is, then it's true, right? So wait, is this what I say? I say that for the base case, n is equal to 1, right? So if we're only going up to 1, right? That means that 1 squared should be equal to 1 times 1 plus 2 times 2 times 1 plus 1 all over 6. And I think that works, right? Because that's 1 is equal to 1 times 2 times 3 over 6. Yeah, cool. 6 over 6. I haven't done much discrete, honestly. I topped out at real analysis, but I do have some other friends here on the stream that have definitely done discrete math. I can definitely explain it. Error bars, yeah. Submit a screenshot. I'll do it. Okay, cool. So this is true, right? So then we need to show that this is true for, like, k plus 1, right? Yeah, k plus 1 goes in for n. Okay. So this is base case. So this is true, right? 1 equals 1. Okay, cool. So, let's say, like, 1 squared plus 2 squared plus blah, 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 right? Is equal to, like, k plus 1. Or n, I think n plus 1. Let me see. Your 1 plus 2 should be 1 plus 1. Oh, yeah, sorry, this one. Yeah, I fucked this one up. Sorry, my bad. Sorry, I said 1 plus 1 is equal to 2. I can try to help with fluid dynamics, yeah, for sure. Okay, so k plus 1. Or, like, what, right? Plus, like, you know, k squared plus k plus 1. Squared? And just see what that would be, right? So that would be equal to... The last one is now k plus 1. Andrew Phillips says, yeah. Or, okay, wait one sec. This part... Liz, if you go to that website down there, actualdiscord.com/submit, there's a link for our streaming calendar. I'll be streaming tomorrow as well. Oh, okay. So, okay. This, right, should be equal to k times k plus 1 times 2k plus 1, right? 2k plus 1, right? Yeah, I think I'm good, right? Over 6, and then plus k plus 1 squared, right? I think so. Yeah? I see. Okay, and then what we're eventually trying to prove is that this whole thing equals this again, but with k plus 1. Oh, man. Oh, that's super cool. Okay, I think I see it. Exactly. Okay. Because then eventually what I'm trying to get this to look like... I can do double integrals, yeah, for sure. Give me a screenshot, dog. Give me a screenshot. I'll do it. I think we're trying to make this look like k plus 1. And then k plus 1 plus 1, right? And then 2 times... There's a Discord, too, if you want to join, yeah? Yeah, more than welcome to join the Discord. I like Discord. We started on Discord, honestly. Wait, then this is +1, right? Okay, so we're trying to make this look like this. I see. Right, because we already showed for just for any base case, for any arbitrary number, right? I can prove that that's true, right? So I'm seeing if I can prove it for the next number, an arbitrary like plus k. And if it is true for plus k, then it's true for all plus k's, which means it must be true for everything. That's how induction works. Okay, but how the fuck do you manipulate this to look like this? That's a mess. What? How? Okay. It's just algebra? Okay, Jeff. It's just algebra? Fine. Ugly algebra, but still. Okay. I see a k plus 1 in both of these things, so I think I'm going to pull that out. So k plus 1. And then we're going to get k times 2k plus 1 all over 6 plus k plus 1. Okay. And then I think I need to expand this out now. The reason why I want to keep this is because I think eventually I want just this and then like this is equal to this or something. Yeah. That's the intuition. So then this is 2k squared plus k all over 6 plus k plus 1. Common denominator, exactly. I agree. So to get these to go with this, I now have to make this 6k over 6. Then this is 6 over 6, not over 7. And then that's k plus 1. 2k squared plus k plus 6k plus 6 all over 6. Okay. But I can group these, right? So now that's k plus 1. 2k squared plus 7k. Oh, this is beautiful. I bet this bitch factors somehow, right? This has to factor. It has to. Yeah? Oh, this is super cool, right? Okay, so, yeah, it does got a factor. Yep. Okay, watch what we're going to do here. I'm going to take this. And so it's like, what? So 2 times 6. I'm going to show you the way I like to factor this, by the way. So I'm going to put 2k squared here. This is like a Punnett square method. I just find it easier. This is 6. And then I need what multiplies to 12, but adds up to 7, right? And that's going to be 3 and 4. So then I'm going to put 3k here. I'm going to put 4k here. And then what you do here is... Yeah, Andrew's already got it. Let me show you how I do it, though. I see, like, what can I pull out of this? I can pull a 2k out, okay? And then it's like this times this is what... How does that get you 2k? Well, that's times k. And then this times this, how do you get 3k? Oh, well, that's 3. And then so, like, this times this, how do I get 6? Oh, that's 2. And so then your answers are k plus 2, 2k plus 3. You can always double check, right? K times 3 is 3k. 2k times k is 2k squared. 2k times 2 is 4k. Yeah. I think you need parents, Andrew, but otherwise you're good. Yeah. Oh, parentheses. Yeah, dude, I was like, yo, you're calling him out on his parents? Savage, dude. Okay, k plus 1. Okay. So then this is k plus 2, 2k plus 3, all over 6, yeah? Oh, which bingo bango. Watch this, watch this, watch this. This is k plus 1, right? And then this is k plus 1 plus 1. That's what this one is, right? And then this is 2k plus 1, because that gets you 2k plus 2 plus 1 all over 6. Okay, and now we proved it. We did it. Yes. Nice. Love it. What's up, Odin Root? I had my first Calc 3 midterm today. One sec, let me read your chat, sorry. I'm gonna send you a question. That was the only one I messed up, not gonna lie. Cool. Do it, bro. Do it up. Thank you, HHH. Okay, cool. What did I prove? Yeah, what the fuck did I prove? I proved this. I proved the first one. Using induction. But that was kind of a mess. Do you see how much stuff we had to do here? Like, do all that? That's a lot of stuff. Okay. So that's really good. Chain rule. Yeah. So again, if you want me to do a chain rule question and explain how the chain rule works, I'm more than happy to. Just give me a screenshot like these students are doing. If you send me a screenshot, I'll do it. All right. Next one we have, great question, Andrew Phillips. Let me help out some other students. If we have time, I'll go through and do 2, 3, 4. But I think for now, hopefully 1 like shows you how it works. Let's do some Epsilon-delta. Oh, can you just go through 3? Later. Yeah. Also, like, maybe tell me, like, right away, like, which one you want me to go through. Just because the queue's already getting kind of long. I got to make sure I do some of these. It's okay, cool. All right, yeah. If you want, Andrew, because I know, like, maybe it's getting late where you are, come by tomorrow's stream and just tell me, hey, can you do number 3? I'll do it. If you're, like, one of the first people here on the stream, I'll do it. Okay, cool. Let's mark that one done. Okay, next is I Love Cats with Epsilon-delta. Epsilon-delta. Yeah, why is the queue should show? What the hell? One sec. I am streaming tomorrow. Yeah, the queue... Odin, I just got 2 people ahead of you. That's the queue right there. It's not too long. Yeah, I am streaming. If you want to know when I'm streaming, there's the calendar. Okay. Find the limit L, then use Epsilon-delta to prove that the limit is L. Okay, well, this is a really nice limit, right? Because the limit of x plus 3 as x approaches 2. Anytime you see limits, just plug it in and see what happens. If I just plug in 2 for here, that should get me 2 plus 3, which should just get me 5, right? Yes, they are linear. Yeah, so we are kind of blessed with that. Okay, but like proving it with Epsilon-delta. I gotta remember, like, there's a... One sec, I need to... Stop. I need to figure out... There's a mathematical definition for it. I need to remember what it is. I need the actual thing. One sec. Epsilon-delta definition of a limit. Because it's about just, like, showing it. Yeah, here, let me see how this works. Becky said it's okay. I can try to untranslate it, or I'm sure we can get ChatGPT. If you want to send the original one, we'll look at it. Let me look at it, Becky, in a bit. Which you're next, so in a second, and then like if I need to translate it, I'll see. Right. Okay. This is it. So you say this. You say okay. This is kind of like the way if we're trying to prove using Epsilon-delta. So it says for every epsilon greater than 0, there exists some d such that f of x minus L is less than epsilon whenever x minus a is between 0 and delta. Okay, what the fuck does this mean? Right? This is so this is the absolute worst thing. I hate Epsilon-delta. But let me kind of show you what we talk about. So, if you have a function, okay, that let's say looks like this, right? And then let's say that let's say this is f of x. And then let's pick a point that we're going to go towards, right? So let's have this be x is equal to a, right? And then this is going to be f of x, which in this case is f of a, right? F of a. Okay? What a limit does is it takes some point along f of x and it starts approaching f of a. So as this point along my function gets closer to x equals a, that's the same thing as the limit as x approaches a of f of x, right? So x, which is the x coordinate here, is traveling along the function towards x equals a, and as it does that, it's going to approach some value, some y value f of x. Yeah. And so usually this is equal to f of a, is what we say. And that's what's happening, right? You just plug in x is equal to a into your function, and you should get the y value at a. Okay, what epsilon-delta says is that here, f of x minus L. So this is saying that, like, the error in the y coordinate, right? So let's say, for instance, there's I think they're calling this the limit then, right? This is L. So they're saying that f of x, which could be like right here, right? This could be like some random f of x. The distance between this and L, absolute value, so whether you're above or below, needs to be less than some arbitrary value epsilon, which means the difference in y from where you're trying to get to and where you are has to be less than some value whenever the distance you are away from x. So this is what I call like delta x minus a is going to be between some value z and delta. I thought I was safe from this while I was at home. Yeah, no, it comes for you. It's like it's unfortunate. I know. I hate it too. It might be instructive to take some example epsilons. Yeah. Yeah. Okay. And then like this right here. Here, this would be equal to delta. This is calculus. Okay. So how this proof works, okay, is we have to like state this and then show that this is like true. And then it's like for deltas between like what? So in this case, f of x is less than L. L is what we think the limit is, which I think the limit's 5, right? So I'm going to say f of x, which in this case is x plus 3 minus 5, right? Absolute value of that is less than epsilon whenever 0 is less than the absolute value of x minus 2, which is less than delta. Yeah, okay. All right, so wait, then from this, right? So this is x plus 3 minus 5. So what? You get like x minus 2 is less than epsilon whenever 0 less than or equal to x minus 2 is less than delta. So I think in this case, are you done at this point? Is this the proof? Oh, okay, whoa. Okay, yeah. Because look at this. Look. X minus 2 is less than delta. X minus 2 is less than epsilon. So you say, which this is equal to epsilon. Delta equals epsilon. Exactly. Yes. Yeah, okay. So you basically just have to show this, and you have to say that delta equals epsilon. Let's show one where it's not so straightforward, which is this one, right? Okay. So they say f of x, which is... Yeah, exactly. Yeah, it's going to be like 2 epsilon or something. So here they do x squared minus 4. So they're taking the limit as x squared approaches... As x approaches 2 of this. And so... as x squared approaches 2... As x approaches 2, x squared approaches 4. So this is x squared minus 4, is this part. This is x minus 2. And then what you do with this is you say, okay, cool. Well, that's between negative epsilon and epsilon. You add 4 to both sides, and then you get to here. Well, and then you square root both sides. And now what you do, is I think you just subtract 2 from both sides. Right? Yeah. So minus 2, minus 2, and then that tells you, that x minus 2, which is the same thing as delta here, has to be in between this. So in this case, I think delta is equal to negative 2 plus the square root of epsilon plus 4. Is that correct? Yeah, I know. I'm sorry to, like, your FYP is filled with... I hate Epsilon-delta. I think Epsilon-delta is absolute trash. I don't know why we teach kids it in calculus. It confuses them. They get so scared, and it's kind of... It's too high of a thing, honestly. It just fucks with people.
No.
Yeah.
No.
It's formal logic. I agree. Which is... calculus is not the time to bring up formal logic. This is the number one ways to get kids hating math. He says Epsilon-delta is cool. Yeah. I don't know. Maybe it's in. Why my LinkedIn open? I don't like my LinkedIn. The kids need to get scared. Yeah, but then they're never going to do math. Russell's paradox, yeah. Okay, so for instance, if you wanted to do this one as well here, I love cats. Dude, excuse me? Okay. This would be, so 2x plus 5 minus, and then when you, L is like what the limit actually goes to. So when we plug this in, this should be negative 6 plus 5, so this should be negative 1. So you say minus 1, cool, is less than epsilon. When 0 is less than x minus 3, so x plus 3. And then delta, okay? So then this turns into 2x plus 4 is less than epsilon. And so if you divide by 2, right, you get x plus 4 is less than epsilon over 2. And we already said, oh, wait, one sec. But I need it to be x plus 3, Jeff. How do I do this? Do I subtract 1? No, sorry. This is x plus 2. What am I doing? One sec. 2x plus 5. Oh, this is plus 1. I have a sign error. Thank you, Lonesome Crow. Yeah, thank you. I fucked up. It happens. So this is 6. Okay. Now I divide by 2. X plus 3 is less than epsilon over 2, right? Which is equal to 2 delta. So in this case, you say delta is, no, sorry. Epsilon over 2, which is equal to delta. Okay, sorry. So you say delta is equal to epsilon over 2. Yeah, this is what you say here. Yeah, epsilon over 2. Cool. So yeah, for those that are like struggling with epsilon delta, this is what you need to do, okay? You need to plug in your function. You need to plug in minus what the limit actually goes to. And then you need to sort this so that it ends up looking like this. This is where the limit's approaching. I can definitely help you with balancing equations. I do tons of chemistry. Yeah, we were doing chemistry earlier today. What do we do with chemistry? We did this. We did like some AGCL and stuff. Yeah. Yeah, if you have a question, again, there's a website down there. Please go submit it. I'm happy to help you. But okay, I hope that helps you. I love cats. Don't fear. Epsilon-delta isn't that bad. Well, I think it's bad. All right. Good job. Silver chloride. My nemesis, dude, right?
Well done.
Okay. Ooh. This is a cool question, Becky. I like your question.
Nice.
Ooh, thank you for the follow, Lionheart. Nice. Appreciate that. Yes, so I can do any question as long as you can find me the question. if you can find me, so like a student did here, right? They submitted a screenshot. I'll do the screenshot live here. Me going and like hunting for questions is not a very good way to help you because I have no clue what level of math or physics you need to know. Yeah. So Nand, yeah, if you have a kinematics test, do you have a practice question from your study guide or something that you want me to go over? I'll do that as well. All right, let's see. This is Becky. Becky says, in a right triangle, CDEF is inscribed such that DC and CF lie along the legs. Okay, E is on the hypotenuse. The length of side EF is X. Okay, so this right here, this side is X, yeah? And the length of the diagonal of the rectangle is X square root of 5. And let angle B be equal to alpha. Okay, so let's call this alpha. Or let me use different colors, sorry. All right, so this right here is going to be equal to alpha. And then the diagonal of the rectangle is X square root of 5. Okay. So then we know this is equal to X square root of 5. Okay. Express the area of the circumcircle of ABC in terms of alpha and X. Drop the other way? Oh, that's actually smart. Thank you, Jeff. Yeah. I think you have the right idea there. Yeah, okay, I agree, Jeff. Let's do it. Oh, because that helps me determine this, like, right away. Right? Express the area of the circumcircle. Okay, so the circumcircle is like this, right? It's something where it hits like all the side. And does it hit them all at 90? I think so. It's the oh, that's the orthocenter. Oh, sorry, the circumcircle is this. Sorry.
Nice.
You're talking about this is the circumcircle, I think, right? Well, that's actually not really working. That looks better. I can definitely do piecewise. Yeah. Okay. Yeah, okay, for those you watching on TikTok, because I know a lot of people asking the same thing. There is a website right there. It's linked right down below. And if you just drop me a screenshot of a sample homework question you have, or a test question, or like, I don't know, like a study guide question, and just hit upload here, then I'll see it, and I can help you work on it. Perpendicular bisectors are involved. Yeah, let's look up the circumcircle real quick. Okay, here we go. Yep, I need this. I need this. Pretty sure I need it. I at least know this is 90. Oh. Bingo. Okay. So for a right triangle, the circumcenter is always on the hypotenuse. So that tells me right away that the length of the hypotenuse is the diameter of the circumcircle. Right? Oh, Twitch is lagging again? It does that. Very cool. Very cool. Twitch, bring my frames back, please. I just want my frames back. Give me my frames back. Okay, this is what we need. This is the cool thing. This is the cool little trig argument. Okay, so we just need this. Yeah? Okay, so let's see if we can get some things then. Okay, this is something with Pythagorean, right? So I know that x squared plus cf squared is equal to 5x squared. So good, yeah. CF squared is equal to 4x squared. So CF is equal to 2x. Love that. Okay, cool. That's useful. So this is 2x. So that means this is 2x. Okay. Getting closer. Oh, man. DC is also x. I agree. This is also pi over 2 minus alpha, right? Yeah, no, yeah. You're good. This is pi over 2 minus alpha, right? Or sorry, yeah, pi over 2 minus alpha. What is it making you think, Aiden, dude? Tell me. I'm curious. X over FB. Yes, tangent of alpha would give me this. I already kind of see this, though, right? So, for instance, I can get this side, right? I can also get this side, yeah? And then maybe they're related to each other or something? If I have to draw another line... I hate when people give me geometry questions and I have to draw another line. What are we trying to find? I'm trying to find the area of the circumcircle. That's what I'm trying to do. Yeah, add them to get the hypotenuse, right? Okay. So from this, right? So sine of pi over 2 minus alpha. Is equal to 2x over AE, right? And then sine of alpha is equal to x over EB, right? And I want AE plus EB, right? Because then I get this, and then we're golden, yeah? So, radius is equal to AE plus EB all over 2. And then just pi r squared. We're done, right? Okay, so sine of pi over 2 minus alpha, that's cosine of alpha, right? This is a good trig identity. So, AE is equal to 2x over cosine alpha. From this, I get that EB is equal to x over sine of alpha. Okay, so 2x sine alpha plus x cosine alpha all over sine alpha cosine alpha is equal to 2r. Yeah? Twice the radius? I think we're good there, yeah? Oh, and is that all I need? I just need the area in terms of alpha and x. Oh, so we're done, right? So then whatever. This is divided by 2. Oh, so this cancels. Oh, no. Don't do that yet. Okay, so then area is equal to pi r squared. So that's equal to pi times this mumbo jumbo all squared. So let's see what we get. So I get 4x squared sine squared. I'm going to say theta for now, just because alpha is a pain in the ass to draw. Plus x squared cosine squared theta plus 4x squared sine theta cosine theta all over 4 sine squared theta cosine squared theta. Okay, cool. Does this simplify? I don't know. I mean, I kind of like see some stuff here, maybe. I was hoping to get like a sine squared and cosine squared somewhere, but I don't. This is like close. Like, I don't want like 2 theta either. So I don't know. What is that? Pi times 4x 4x squared. Yeah, I see that. Cosine squared theta. Are you talking about this one? This is the double angle. I really don't want to do stuff with double angles, right? I don't want to start having different thetas. Whatever. This is 4x squared over... Oh, the last term in the numerator. Yeah. Yeah, that's a double angle. I agree with that. I'm a sub. Thanks for the sub, bro. Love the subs. Yeah. I don't know. What's that? X squared over cosine squared theta plus x squared over 4 sine squared theta. All right, if we cancel these. And then plus x squared over sine theta cosine theta. I think that's the simplest I can make it. This 4 like fucks with things, dude. I don't know. You tell me, Becky Beck. Becky Beck, is that okay? Am I allowed to do that? And then determine the value for alpha, which it's minimized. So then I gotta do dd theta of this? Oh, that's a mess. I don't want to do that. Okay. Here, let's throw this at ChatGPT, see if it can do something. No, not that. No, that was our induction proof. Where was the other one we had? Oh, wait, here we go. Okay. Blah, 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 blah. Ooh, okay. There's a tangent theta and a cosecant squared. Uh-huh. I think we get probably the same thing. Yeah, what's the final answer? Let me know. I'm just curious. You can also submit it as well using the same website if you want. So let's see. How do I submit a screenshot? There's a website. www.actualdiscard.com/submit. That website down there. Just go to that website and then you'll see something that looks like this. Drag and drop your screenshot in, put your username, hit upload. Follow us on everything. I hope to be intelligent as you. You should see me. I get really stupid on the weekends. I'm not that intelligent. Okay, let's see. Femvox got pi x squared times tan of alpha squared plus tan alpha plus 5 over 4 plus 1 over tan alpha. Dude, that's a mess. Oh, no. This is what they got, which... If I pull out a cosecant squared, do I get the same thing? I don't know, actually. We agree there's a pi x squared coming out, right? We're cool with that? We like that? Yeah, let's get rid of this. So, what is that? And they want me to pull out a cosecant. Oh my god. Yo, what? No. Wait. So, pi x squared, and then I get, secant squared theta plus 1/4 cosecant squared theta plus, I don't know, this is kind of annoying. 1 over sine, that's cosecant, secant? Secant theta, cosecant theta? If you pull out a cosecant, coaster ghoster, cool. I see your question. You're good. Nice, Becky sent it to me. This is nice. Look what they have. This is apparently the answer. Let's see if that comes out to be the same. Yeah, I got you. Okay, so... wait, where'd the A come from? Oh, A is X, I guess. Yeah, A must be X. Okay. Let's see if this is the same answer, by the way, sorry. So this is, 4 over cosine squared theta plus 1 over sine squared theta plus 4 cosine theta sine theta. I think it's the same thing. No, you're good, you're good. I think, okay, and then this is all, right, times pi a squared over 4. So watch, this will cancel. This will cancel. And then this has to have a 4 on it. And so you do get the same thing. We get the same thing. Because then that's pi a squared. 1 over cosecant, that's secant squared. Plus 1/4 cosecant squared. Plus secant cosecant. Yeah. Okay, cool. Wow. Okay, so it is the same. This is really clever how they're doing this. I don't know necessarily how to backwards engineer that. That's kind of difficult, I would say. But we do get the same answer. Because at the end of the day, so that's for the first part, right? The second part is to determine the value of alpha for which area is minimized. Sorry. So, yeah, take the partial and optimize. So for this, now you do dd. I'm going to say d theta. I just don't like alpha. Of that whole thing. And see what you get. And then you set it equal to 0 and see what we have. So, yeah. Oh, it's okay. A little spoiler alert for you, dude. You get to see some new stuff. So this is pi a squared over 4. And then this is a chain rule, right? So you have to say times 2. 2 over cosine theta plus 1 over sine theta to the first power, right? So pull the 2 down, drop the power by 1. And then you have to take the derivative of what's inside. So derivative of secant is secant tan. So you get 2 secant theta tan theta. And then derivative of cosecant is... I don't remember all my derivatives. I'm not an alpha male, no. I'm a sigma dog. Okay. Cosecant is negative cosecant cotangent. And then secant is secant tan. Wait. Did I have that right? Yeah. Okay, so secant is secant tan. I had that right? Secant tan. And then it's negative cosecant cotangent. Okay. And then set all this equal to 0. Okay, so you have a couple options, right? You can have this, or you can have this equal to 0, right? The nice thing is this is more or less factored, right? You have this times this equals theta is equals 0. So you either have 2 over cosine theta plus 1 over sine theta is equal to 0. Let's try to solve that real quick. So, I don't know. If I, like, move that over. So 2 over cosine theta equals negative 1 over sine theta. So then 2 sine theta equals minus cosine theta. If I just, like, cross multiply these, right? So then... Oh, sorry. Sine theta over cosine theta is equal to negative 1/2. That's what I should have done. Sorry. Yeah. This is the last problem of your last year of high school? Wow. This kind of sucks. Okay. Tangent of theta is equal to negative 1/2. So that's one of them. Yeah, right? Did we do that right? Sorry, if I multiply that through by sine, I get 2 tangent plus 1 minus 1. Okay, cool. Okay, so this is one of them. So theta either equals the arctangent of negative 1/2, or all of this equals 0, which, Jesus Christ. Okay, so secant theta tan theta is equal to 1/2 cosecant theta cotangent theta. Okay, I like putting things in sine and cosine just so I can see things at least. So secant is the same as 1 over cosine, and tangent is sine over cosine. So I have sine squared theta. Wait, no, sorry. Sine theta over cosine squared theta is equal to 1/2. Cosecant is 1 over sine. Cosine over, okay, 1/2 cosine squared over sine theta, right? No. Cosine theta over sine squared theta, sorry. Right? Cosecant's 1 over sine. Cotangent's cosine over sine. Yeah, okay, cool. Alright, cool. So, sine to the third of theta over cosine to the third of theta is equal to 1/2. Holy cubes. Yeah, okay, cool. So, tangent to the third of theta is equal to 1/2. So, tangent of theta is equal to the cubed root of 1/2. I don't know, bro. What? Okay, so theta is equal to the arctangent of 1/2 to the 1/3. Okay. As to, like, which one is the minimum, you just need to plug it back in. I really don't want to do another derivative to, like, figure out the concavity of this. I'm guessing it's one of these. I think ChatGPT said it says this one did it. Oh, here's the interesting thing. Okay, so wait. Theta has to be positive though, right? Yeah? Yeah, so this one doesn't work. You can't have negative angles. So it has to be this one. Which is also what ChatGPT said. And then, if desired, you could plug it in. Cool. We ended up getting the same answer. That's actually really cool. I always appreciate when that happens, Becky, right? Yeah, there we go. Nice. Good question, Becky. Thank you, Becky. Cool question. I liked it. If you want to join our Discord, I will post this in the chat so you can see it. Let me see. This is Becky. What is arctan? Arctan is just the angle such that the tangent of it is equal to that thing. That's how arctan works. One sec. Let me drop this for Becky in our Discord. Yeah, you can also join our Discord and just, like, ping me if you can't find it. But I posted it it's in the chat there for you if you want. Because that was kind of cool. We had to do all that stuff. But yeah, Spark the Goof. Yeah, so for instance, arctangent of 1 is the same thing as saying tangent of what gets me 1. This is also called, like, inverse tan, like this. Same thing. How it works is, like, sometimes you'll have, like, for instance, yeah, right, tangent of theta is equal to 1. And you're like, wait, what angle when I take the tangent of it do I get 1? So in order to release the theta, you can't divide by tangent. That's not a thing.
No.
You can't do this. That doesn't work. But what you can do is you can operate on both sides by an inverse function. So I can take the arctangent of both sides. Okay? And arctangent of tangent, that kills that off. And so then you get theta is equal to the arctangent of 1. So arctangent takes the ratio of tangent and then tells you what that angle is to get you that ratio when you would take tangent of it. Yeah, that's the difference. Go, Eric. So what happens is if you have an angle theta, right? Tangent of theta gets you the ratio of the opposite over the adjacent. But doing the arctangent of the opposite over adjacent gets you the angle. This is why they're called inverse functions, right? Tangent of theta gets you the ratio of the sides. Arctangent of the ratio of the sides gets you the angle. So it depends which one you have. If you have the angle, it helps you figure out the ratio of the sides. If you have the ratio of the sides, arctangent helps you figure out the angle. And that's how those two things work. Yeah. All right, nice. Coaster Ghoster. Or actually, Odin. Odin, you still here? Odin? Thanks, Femvox. Yeah, I think it's a pretty cool explanation. Odin, what's up, big dog? Is Sir Odinroot here? Yeah, he says, yeah, big dog. All right, cool. And then Coaster Ghoster, you're next. Cool. There is a queue, and then I always kind of like show it sometimes. This is the queue so far. So, Becky, we just did her question. So I'm going to remove it from the queue. One sec. I have so many windows open right now. Okay, so we'll clear that. And then Becky's number 3. That was her giving me the solution. So there you go. I did not push my office hours later. I'm just streaming longer. We've been on for 2 hours, 20 minutes now. I am streaming on Thursday, though, now. As well as... let me see. One sec. I gotta answer all these phone calls. Okay, I'm not gonna worry about this. As well as Sundays, I'm gonna try to do. Yeah, for sure. Yeah, if you want to. Yeah, for sure, Becky. Yeah, just at me or here. Is your name Becky in our thing as well? I tagged you what channel your solutions are in if you want to look at them. How do you submit questions? Good question. Right here. There's a website. It's that actualdiscord.com/submit. Go to that website, drop a screenshot in, put your username. I'll do the question. Integrate x arc sine of x. All right, let's see. All right, this one's from Odin. Use vector algebra to show that a parallelogram with diagonals of equal lengths is a rectangle. Cool. All right. Well, I know the area, right? So, area of a parallelogram, right? Isn't that equal to A cross B? Is that right? If this is like A and then this is B, you can like think about this. Or am I thinking the volume? I think that's how that works. Derive the consequence of the diagonals have... Yeah, so if the diagonals have... Oh, wait. With diagonals of equal length. Isn't that the definition of a rectangle? Is that the diagonals have equal length? So, yeah, rectangle. Yeah. So let's try to let's think about this, right? So if you had a rectangle, okay, And then sure, let's call this like vector u. Let's say vector u goes this way. And then let's say that vector v goes this way. Okay. Then this diagonal, that's equal to u plus v. And then this diagonal here is equal to u minus v, right? You're welcome, Becky. U minus v, right? Okay. Okay. Oh, very cool. One sec. So I think we want to show... Okay, this is actually really cool. So actually, screw this. I don't need this. This works for like 3D. Okay. I think I get this. I understand this now. Okay. So if this is equal to this... Okay. Then also, the dot product of these two things should be 0. Initiation. Oh, good thing. Turn off all your shit. Get off my stream. Put away your phone and just stare at it for a couple minutes. Sometimes it helps for me to have a snack. Like, I'll have like a thing of like, I don't know, chocolates or like peanuts or whatever. Like, I don't know. And if you just sit there with the thing and then a thing of snacks and you eat, usually once you finish your snacks, you're like, oh, I have to do this. And that kind of helps. Or, if you don't have anything close to you to kind of get you started, setting like a timer saying, I'm going to stop doing this in 50 minutes might also help. I think it's called like Pomodoro timers. I've seen that work before. Okay, this is actually, I think this is really cool how I think about this. Okay, wait. So, u minus v, I'm trying to think here. Yeah, okay. So if they're equal, then u minus v dotted with u plus v has to also equal u plus v dotted with u minus v, right? Or, ooh. One sec. I mean, that makes sense. That's associative property. Okay, wait. I think I'm getting closer. Okay, one sec. The magnitude of u plus v, because, wait, they said that diagonals of equal lengths. Okay, so that means that u plus v and u minus v must be the same, right? And in order to get the magnitude of this is the same thing as u plus v dotted with u plus v, right? In order to get magnitude. And then, well, it's like the square root of it, right? It's dotted with itself, but then square rooted. And this must also equal u minus v dotted with u minus v, right? That's how you figure out magnitude, yeah? And so this will get you u squared plus v squared plus 2u dot v. We assume u dot v and v dot u is the same, right? And this will get you u squared minus v squared minus 2 u dot v. Okay. This cancels with this. So then, oh, it's, sorry, this is still plus v squared. Yeah. Sorry, this is plus v squared. Thank you. Thank you. Minus v is v squared. Yep. This cancels with this. And now I get that 2u dot v has to equal negative 2u dot v. And the only way for this to be true is for u dot v to equal 0. And if u dot v is equal to 0, that tells you that u is perpendicular to v. And if u is perpendicular to v, that means this is a 90-degree angle, which means that these two sides are parallel, and these two sides are parallel. But also, I think by definition of a rectangle, if this is 90 degrees, then this is also 90 degrees, and then this is 90 degrees, this is 90 degrees. Now you got a rectangle. Yeah. Okay, I think that's where that comes from. It's 21. Let's go for burgers now. I want burgers. Please. Ever thought about doing architectural engineering? I haven't. I mean, I'm 35. I've kind of gone through a lot of school at this point. I don't really want to go do more school. Okay. Odin root. Does that make sense? So this is diagonals, same mag, and then this is showing that u and v are perpendicular. And yeah, if the two sides are perpendicular, you have to have a rectangle. I mean, I guess, could you have this maybe? I mean, these two sides are right. I mean, this is trying to think like another case that this could happen. I don't think it can, right? There's no other way to have two 90-degree angles, right? It makes sense now? Okay, cool. That's a tough question, though. Honestly, I wouldn't have got that off the rip. That requires a little, and especially if this is like the last question on your test. The only way to really know this is to have done it before. Right, exactly. Not if it's a parallelogram. Okay, cool. Good question there. Odin Root, I appreciate it. All right, Coaster Ghoster. Let's see what the what's my preferred way to study? My preferred way to study is to do, right? I like doing things. So yeah, Coaster Ghoster, you're next. Let's do Coaster Ghoster question. It was only 8 points, so you still get an A, dude, right? All right, let me copy this image in. Pasting it. Oh. How long did we go for? Oh, man. Almost 2.5 hours. We've got through a lot of questions today. 19 follows on TikTok. That's dope.
That's dope.
What are we at on, looks like 4 follows on Twitch. I don't know. A bunch of views on YouTube. Still uploading. Oh, this is a big image you sent me. Coaster Ghoster sending me a big image. It'll come in eventually. Okay, there we go. Cool. All right. I assume this is the one you need help with, Coaster. Write an equation in factored form. Is this x squared? It's a little blurry. I'm trying to determine like what this is versus this. It is x to the third. Cool. Thank you. That'll help me out. And is this x squared? Yep, cool. Awesome. Okay. All right. Let me just do all these on something else. So x cubed minus 9x. And then over x squared plus 2x minus 15. Okay. First thing they want is factored form, right? So we want to try to see what we can pull out of the top. I already see I can pull an x out of both things, right? So that's going to be x times x squared minus 9. This is special. We'll see it later. Let's do this. So here, Coaster, I say what multiplies to 15? Negative 15, but adds to 2. That's going to be 5 and negative 3, right? Because 5 times negative 3 is negative 15. 5 minus 3 is 2. So now I have x plus 5. Or, no, sorry, it's... Yeah, it's x plus 5, x minus 3, yeah? Okay. Even further, this is special. This is called a difference of squares. So this is going to be x plus 3, x minus 3, all over x plus 5, x minus 3. And I think that's it in factored form. I'm not going to cancel anything yet, because I want to show you why. What in the partial fractions? If we had to integrate this, yes. Did I fuck up, Jeff? What did I fuck up, dude? Oh, okay. He says okay. Okay, I did right? Okay, does it make sense so far, Coaster Ghoster? Yeah? Good, that's what you got. Nice. I agree, it's correct. Find any zeros. Okay. So zeros, that's where the numerator is equal to 0. But then you also need to make sure the denominator doesn't also equal 0. Yeah, Fleming, I got yours. Yours is right here. I see it. Don't worry. It's a little bit down on the queue. It's number 5, but we'll get to it. Okay, so you have to check where the numerator equals 0. So that's at x is... You have x equals 0, comma, negative 3, comma, positive 3. However, you need to make sure that these numbers don't also make this equal to 0, because then that's 0 over 0, which is bad.
Disqualified.
You don't want to do that. So 0 is fine, because this doesn't turn to 0. Negative 3 is fine, because this turns to minus 6. Plus 3 does not work, because plus 3 would cause both of these to be 0. So this is not a 0. This is actually going to end up being something special, which is called a hole. A hole is where you get 0 over 0, or in this case, where these two cancel. If you want to submit a question, there's a website, actualdiscord.com/submit. Just do that. That's the website. Right. Okay, so where there are holes, so the holes is also called a removable discontinuity. Yeah. That's the better way to call it. And that's at x equals 3. Finding vertical asymptotes. So vertical asymptotes occur when the denominator is equal to 0. And then at this point, we can get rid of the... We don't need to worry about these. And so that only happens at one place. And so that's x is equal to negative 5. Horizontal asymptotes. Great. Yeah, so there are some rules you got to look at. In this case, I mean, you can take the limit. If you want to take the limit, you could do it. But I don't think you're doing limits yet. That's more of a calculus thing. So you just look at the degree, which is what's the highest exponent power on the top. And then the degree on the bottom, which is the highest exponent power on the bottom. And in that case, this one is bigger than this one, which usually would not have a horizontal asymptote. However, if this degree is 1 higher than this degree, then yes, you get what's called a slant asymptote or an oblique asymptote. So horizontal asymptote is technically slant. Yes. And then find the domain. Cool. So the domain is everywhere as long as the function doesn't break. So the function only breaks at this vertical asymptote. So I would say the domain is from negative infinity to negative 5 union negative 5 to positive infinity. I think you include the discontinuity. Correct me if I'm wrong. Do you include the removable discontinuity in the domain? You got to train obliques to save that. That's a good joke. I appreciate that one. Ash, that's good. Great. I love that. That's great. Oh, you shouldn't though. Okay, you do have to remove it. Yeah, okay, so there is no value at 3. Okay, so sorry, we do gotta fix that. Okay, fine. So 3 union 3 comma infinity. Yeah. Don't trade obliques, you'll get a wider waist. Yeah, we're trying to keep the aesthetics, dude. Anyways, okay, cool. Nice. Does that make sense for you, Costa Ghoster? I definitely do calculus. Yeah, I was doing some nightmare level calculus earlier. What was it? Where was the nightmare calculus we were doing? Yeah, this shit. Bless Robbie for asking this, but yeah, we were doing some nightmare level calculus, and then yeah, we did some integrals here. That was cool. We did some chemistry. Okay, cool. All right, great. Awesome. Nice. Good job, Coaster Ghoster. Yeah, you just put slant asymptote. Now, I mean, here's my question. I forget if a slant asymptote is an asymptote or if it means there's no horizontal asymptote. One sec. Is slant asymptote... Yeah, good. There you go. Jeff has it right. Jeff says a slant asymptote is technically not a horizontal asymptote. So you say no horizontal asymptote. Yeah. Yeah. Okay. Right. So this, you technically say none, but you can say... what do you say? It approaches a line. If you want to figure out what the line is, it's pretty cool. You end up just doing long division. Yeah, if you wanted to do this, this would be x squared plus 3x divided by x plus 5. Yeah, no, you're good, Caleb. Yeah, send me a sample question with the chain rule. I also have videos on the chain rule if it's like confusing. Search on my profile. I have them all over the place. Yeah, if you wanted to do this, you want to get rid of this so that you have like the simple form without the hole, right? And then you get to here, and then you just do like long division. So x squared plus 3x divided by x plus 5. So x plus 5 goes into x squared, x times. You get x squared plus 5x. Subtract. This goes away. Get minus 2x. X plus 5 goes into this. Minus 2 times. So then you get minus 2x. Minus 2x minus 10. Right? This is gone. So then your answer is y. So you get y is equal to x minus 2 plus the remainder, which is 10 over x plus 5. Right? This is the slant asymptote. And here's the cool thing. The limit as x approaches infinity, this eventually goes away. Right? Because now you're doing 10 over a really big number. So your function eventually approaches a line which is y is equal to x minus 2. You might see, it might look something like this, for instance. That's like kind of how like it approaches it. Why do you need to know how to do this? Because in differential equations, long division comes back. Yeah, for sure. Yeah, this is, I mean, long division, you learn it, and then it gets used in so much shit. Pietro, what's up? Dude, we have the same last name, by the way, bro. Mi chiamo Giovanni Rossi. The John Smith of Italy. That's cool, we have the same last name. It's a very common last name. Okay, let's see. Clickbait. All right. But yeah, that's how that works. Piacere, yeah. I always joke when I go to Italy, people like don't believe my name is real because my name is like the John Smith or like Jane Doe of Italy, and they're just like Giovanni Rossi. Yeah, sure, dude. But like, I shit you not, it's real. Like, if you go check out my this is my PhD thesis I did. Here, I'll drop it in the chat. It's funny. Where's my chat? There you go. Yeah. It's real. It's actually my name. Yeah. There's if it wants to zoom in. Whatever. Allow cookies. Yeah. It's real. PhD, goddamn. Yeah, I've done a lot of stuff. But I like to stream. Okay, let me see. This is from Clickbait Derek. Oh, and also let's clear the latest question that got done. So Coaster Ghoster, done. Nice. Clickbait Derek. Okay, so am I actually supposed to solve this, or is this like ridiculous? The potential energy of a one-dimensional mass at distance r from the origin is as follows. With u naught r and sigma are all positive constants. Find the equilibrium position r naught. Let x be the distance from equilibrium. Show that for small x, the potential energy has the equation form. U is equal to that. Oh, okay, cool. Okay, so equilibrium is where du dr is equal to 0, right? You need du dr. Wait, does it need to be? Yeah, we didn't say it had to be stable equilibrium, right? If it was stable, then I need the concavity to also be positive. Sounds like a fashion house from Italy. Yeah. Okay. I think du dr has to be equal to 0 here, right? Oh, you're more worried about the energy equation. Okay, cool. All right, so we already know how to do that then, right? Okay. All right. You want this? You want the potential energy form? So, okay. So this, I think you need to do like a Taylor series on this, right? Is that right? That's anytime we have small oscillations, it means small delta x, delta r in this case, right? Yeah, it's a binomial expansion. Okay, cool. Sorry. R is the distance, correct. So it's interesting that R like shows up in two different places. You have R here and you also have R down here. It's kind of annoying. Okay. So, yeah, let's assume that R minus R0 is, like, much less than 1, right? And then we have to do, like, a Taylor expansion. But I think we need to know what R naught is. So here, we got to get it first. Big Glizzy, beautiful name. Thank you. This is physics, probably, I would assume. Whatever, let's just do it. So, du dr is going to equal to mu naught. That's 1 over r minus lambda r over r squared, right? This is not AP Physics. There's no way this is AP Physics, dog. Do I have that right? I think I do, yeah. And then we just got to solve, right? Okay, cool. Oh, you already got this. Right. Good. And you say this is stable equilibrium. I agree with this. Wait, sorry. That's not what you wrote. This is what you wrote. Yeah. Thank you. Yeah, I agree with this. So, yeah, if people want to see how it works. Yeah. That is correct. Because this goes away, right? You're just left with lambda r over r squared is equal to 1 over r. Oh, sorry, is equal to 1 over big R. So then r squared is equal to lambda big R squared. I'm missing a lambda somewhere, though. Oh, lambda squared. I fucked up.
Surprise, motherfucker.
I forgot about the lambda squared. Okay. Cool. All right. I'm assuming that it's just the equilibrium. So r is equal to lambda r. Perfect. Love that. What subject is this? I'm guessing it's classical mechanics. Classical mechanics 1. Okay, so this is undergrad physics, college level. Mechanics. Okay. So now, we need to figure out the expansion. So, UR is equal to... Yeah, okay, here we go. One sec. Let me copy this. I actually want all this. Here, I want this. Okay, so that's that, right? And then we already figured out this. So whenever we have small oscillations, I know that's going to be for what is this? R minus R naught. I'm just going to start calculating derivatives. And usually we just go to like second order, right? Because we have kx squared here, this tells me already I'm only going to second order. Yeah. Okay, so I probably just need the second derivative then, right? So d squared u dr, that's equal to u0 2u0 pi squared big R over r to the third, right? Yeah. Okay. And then for a Taylor series, let's get it. Taylor series. I just need to remember it. I know it's like x minus r, whatever, something squared. Yeah, that's what I want. Thank you. Taylor series. Yeah. It's this. And we're going to be centering this, right, at a is equal to r minus r naught, right? So the first thing I'm going to be doing is f of r minus r naught, right, plus f prime. So plus f prime at r minus r naught. I think. Or wait. Yeah, no. Oh, wait. Okay, sorry. This is at R. This is R naught. It's centered at R naught. Sorry, that's right. Sorry. A is equal to R naught. And then we're looking for the function as a function of R. For R minus R naught is small. Wait, the tangent line is just the Taylor series expanded to the linear term? That's cool? Yeah. Yeah, it's pretty cool. It's like a linear approximation is what it is. Okay. Okay, so this is f of r naught. This is now f prime. No, this is f prime at r naught, and then this is r minus r naught. Okay. And then this is plus f double prime at, what's up, equity? R naught, and then this is r minus r naught squared all over 2 factorial. Okay. So f at r naught, that's equal to u naught r naught over big R plus lambda squared r over little r naught. Maybe. I do it. My Q is, what is my Q at now? What the fuck's my Q at? What does the Q say? Is that 9? Is that 9 questions already being asked? Wow. One second, where is it? Yeah, 6. Okay, maybe. I'm getting through as many as I can here. Okay, f prime. So then that's this evaluated at r naught. Okay, so then that's equal to mu naught 1 over big R plus lambda squared r over r naught squared. Lambda squared r over r naught, yeah, okay. And then that's evaluated at r minus r naught. And then plus f double prime. So that's 2u0 lambda squared r over r naught to the third. Right, r is the distance, yeah. I agree. And then this is r minus r naught squared. Okay. All right, what does this become? Oh, but then is R naught the equilibrium position? Yes, and then R naught, this is this, right? Is equal to lambda R. Oh, very cool. Okay, so this is mu naught lambda R over big R. Or sorry, it was lambda, yeah, lambda big R, sorry. Oh, very cool. Plus lambda squared big R over lambda big R. Cool. Cancel, 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 cancel. This is equal to 2 mu naught, right? That's what the first term goes to. All this goes to this. Okay, and then this is plus mu naught 1 over r lambda squared big R, and then this is lambda squared big R squared. So this just goes to 1, right? I feel like it does, right? And wait, isn't there a minus here? Yeah, this is a minus. Oh, this goes to 0. Oh, look at that. Okay, that's minus. This is minus. Cancel, cancel. Cancel, cancel. This goes to 0. This whole term goes to 0. And then you're just left with this one. Oh, this is super this is super dope, honestly. This is cool. R over, and then what was that? Lambda cubed, big R cubed. And this is R minus R naught squared. Okay. So this becomes plus 2 mu 0 over lambda R R squared. And then it's R minus R naught squared. Okay. Cool. Okay. And then this thing is left here, right? So 2 mu 0. So, yeah, okay, okay. So now energy as a function of R is equal to 2u0 plus 2u0 over lambda. Oh, and I think, oh, and there, I forgot, there's also a 2 factorial here, sorry. So 2 factorial. Dude, so many terms you got to keep up with here on this one. Sorry, 2 factorial. So this is 2 factorial, right? So this goes away. Okay, so now it's this. Oh, wait, I gotta refresh my screen. We've been streaming for too long here. Okay. Okay, so 2u0 over 2, so that cancels. So u0 lambda r squared, r minus r naught squared, and the r's and lambdas cancel. I don't think the r's and lambdas cancel, do they? Oh, where it runs out of potential energy. Yeah, one second. We've gotten like way up here. So I just want to show it's u is equal to constant plus 1/2 kx squared. Okay, cool. So this right here is my constant. And then, so usually u is equal to constant plus 1/2 like delta x, 1/2 k delta x squared. Right? This is like this spring constant. Delta x refers into this case to r minus r naught. So this is the constant plus 1/2 times k, which k in this case is mu naught over lambda r squared, but you need another 2 here in order for this to equal this. And then this is like delta x squared. Okay, cool. So that tells me that k is equal to 2u0 over lambda r squared. And then if I want the frequency of small oscillations, from this, which is Hooke's law, right? Omega squared equals k over m. So omega is equal to the square root of k over m. And now this is equal to, thank you, Sib. This is the square root of 2 mu naught over lambda r squared m. And I think that's it. I think that's your omega. Is that what it is, clickbait? Jesus, look at all the stuff we had to do. We had to go all the way down here. I love how my writing just started getting bigger and bigger. Yo, what the fuck? How'd you get into vibrations? Well, we saw something that looks like 1/2 kx squared. And that's the classic potential energy for an SHO, simple harmonic oscillator. And so then we do this a lot in physics. We just say it looks like this, so it must be this. If it walks like a duck and it quacks like a duck, it must be a fucking duck. Anyways, like, Jesus. This was cool. At this point, ask your professor. There. There you go. I'm gonna send you the screenshot clickbait so you can see it. Also, yeah, you get a point for asking that question. Oh, so does Becky, by the way. Yeah. Good stuff. Thanks. Yeah, cool. Thanks for the question, dude. That was fun. I got to relive some physics. Jeff's favorite. All right. Let me make sure. Okay.
Well done! Well done!
I got an extension. I was gonna have to go in 5 minutes, but I got an extension so I can help out more of you guys. All right. Let's see. How are you streaming? It's 10 p.m. It's only 8 p.m. for me right now, dude. All right. So that was clickbait's question. So let's mark clickbait is done. Next is Perseus, who's been waiting for 40 minutes. This is cool. I can see the time now that you guys submitted them. Honestly, I'm just trying to get to the monetization requirement on YouTube, which is so many goddamn watch hours. What about stats, Jeff? Do you want some stats? We got stats for you right now, dude. You want some stats? We're going to do some stats. Which phrase best describes the strength of this relationship? How would you relate our relationship, Jeff? How would you rate this? Very weak. It's at least consistent, though. Right? Yeah, I agree. I agree. This is very weak. It's constant, right? Yeah, no matter what X is, Y doesn't really matter. If it was like this, then this would be like totally random, I guess. So, zero slope. I mean, so I'm curious. What does that mean? The scatter isn't that bad. And if I were to do a like a residual plot of this, it probably wouldn't be the worst thing in the world, right? Nice clickbait, yeah. Zero slope means it doesn't change. Yeah, Y doesn't change with X. So, I mean, what do we say? I guess it's weak, right? Yeah, very weak. Okay, cool. We're going to go with very weak. Nice. Okay, cool. All right. Ooh, nice. Very weak. Okay, cool. Great question there, Perseus. Appreciate it, dude. Perseus done.
Well done! Well done!
Probably. You're almost next here. We just got done with so now we just have sorry. We're gonna do Eric's and then Fleming, you're next. Cool. I will work my hardest to get through everyone's questions. Okay, let's see. If y equals e to the u and u equals sine 2x, show that dy dx squared is equal to d squared y du squared times du dx squared plus dy du times d squared u dx squared. You must use calculus and show any derivatives. Okay, great. Well, let's go figure some shit out, right? Okay. So let's see. dy du. Well, the derivative of e to the u, that's just e to the u. And then d squared y du, that's the derivative of dy du. Well, derivative of e to the u is just e to the u, right? Cool. Nice. Easy. Let's look at dx du. So that's a chain rule, right? So sine 2x is going to be cosine 2x times the derivative of what's inside, which is derivative of 2x is 2. So this is this. Yeah, we're getting to it. We're getting to it. Okay. And then yes, and then I will do But that was a dx, not a du. Sorry, where? This says y equals e to the u. Oh, the leftmost thing. This. Let me see. Well, one second. Well, we'll get to it in a second. So it's probably not a perfect question. Maybe not. We'll see. D squared x du squared. Oh, I fucked this up. Sorry. Sorry, I did du dx. Oh, no.
Surprise, motherfucker.
I did it wrong. I messed up. Sorry. I got ahead of myself. Okay. I will agree we did dy du, right? Okay. I need to get du dx. Oh, no. This is du dx. No. What? Sorry, I'm messing myself up. Du dx is equal to 2 cosine 2x, right? And then d squared u dx squared is equal to negative 4 sine 2x. Yeah. It's okay. Yeah, I messed it up too. It's okay. Okay, so d squared y du squared. That's this one. So that's e to the u. And then du dx is here, but that's squared. But not the second derivative. It's doing the result squared. So that's going to be 4 cosine squared 2x. And then plus dy du. Well, dy du is just e to the u. And then d squared u dx squared is this one. So then negative 4 sine 2x. Okay, cool. So putting it all together, what do we get? We get e to the u. I'm going to say 4e to the u. And then we get cosine squared 2x minus sine of 2x. Right? Is that it? Yeah, I think that's it. Let me throw it ChatGPT real quick. Just double check that I'm not insane. I'm the best teacher you got? Oh man, I'll take that. That's a cool compliment. Okay, I think that's what it is. Let's just see if ChatGPT can do it as well. Blah 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 blah. Oh. Yeah, but yeah, there is one more thing we got to do, right? Okay. I have to replace u. This is why AI is useful. AI, like, it finds like little small mistakes, right? U is signed to the 2x. So this is 4e to the sine 2x, right? Remember that u is equal to this. Why is there so many more people on YouTube than TikTok and Twitch combined? I don't know. It's just how I do on the algorithm. Like, I do better on certain platforms than others. Also, like, views doesn't necessarily indicate, like, community. I'll get a lot of views on YouTube, but they tend to be, like, coming and going. Whereas people on Twitch tend to stay around for a while. Cool. Yeah? Thank you, sir. Very appreciate it. Nice. Okay, awesome. Dope. I guess Jeff is saying that I could have also just like substituted this in. Is that what you're saying, Jeff? I could have said like y is equal to e to the sine 2x, and then done d squared y dx squared. I think that's kind of what he's saying. So wait, yes, Jeff is saying that. Okay, so one sec. So, dy dx in this form is okay. So it's e to the sine 2x, but then you need to take the derivative of what's inside here. So that's a chain rule. So now that's cosine 2x, but now I need to chain rule cosine of 2x. So that becomes times 2. So it is a chain rule, right? Okay. So this is equal to 2 cosine 2x sine of 2x, yeah? And then to do another derivative of this, this is now a product rule. Sorry, e to the sine 2x, sorry. It's not sine to the 2x, sorry. E to the sine 2x. Yes, I agree. Yeah, no. So, it shows... Yes, yeah. Yeah, so, and now we do the product rule. Okay. Yeah, hold on. We got it, guys. Don't worry. Okay. So let me do it real quick. Okay. So then d squared y dx is going to be a product rule. So that's 2 times the derivative of this, derivative of the first, which is going to be negative sine 2x times 2. So let's pull a 2 in here. E to the sine 2x plus the derivative of the second, which is, oh man, 2 cosine 2x e to the sine 2x times the beginning, which is, fuck, what was that? Sorry. Cosine 2x, which, yeah, okay, times cosine 2x. Yeah, sorry, sine 2x. Yeah, I'm just dropping all my 2's and shit. Okay, so now, this is negative 4 sine 2x e to the sine 2x plus 2 cosine squared 2x e to the sine 2x, which is the same thing as pulling out this. And I'm missing a 2 here, sorry. Yeah, sorry. This is e to the sine 2x times sine 2x, or no, sorry, cosine squared 2x minus sine 2x. Is that the same thing? It is. Yes, cool. Yes, we did it. I'm happy.
Oh, we're so sorry to hear about your brother that passed away.
5 big booms. Okay. Okay, we proved it. We proved it. We proved it for you guys. Yes. Sine 2x, not... Oh. Wait, what? Yeah, oh, okay. Well, yeah, sorry. I had that one wrong, too. Cheers. Bro, what? Bro, what? I'm okay. Yeah, right here? Okay, cool. Nice. Okay, cool. Oh no, that's sad that your brother passed away. He gets 5 big booms. Bro, I think that moment is real. You want to go find it real quick? Big Justice brother passed away, dude. I'm pretty sure this is healing from griefs. Big booms from Sam, dude. Here we go. Yeah, apparently it's real, dude. Thanks for all the follows, by the way, guys. Here we go.
Hear about your brother that passed. Oh, we're so sorry to hear about your brother that passed away. He gets 5 big booms. Boom! Boom!
Bro did not die for this. Dude, I don't know. Apparently it's real. Okay, nice. Good job, Eric. We're gonna mark you as done. And now, Andrew Fleming, you're next. Cheers from New Zealand. I do like Kiwis. Okay, cool. On what values of x in the interval -2 to 3 is f non-differentiable? Explain why. Okay. So my professor never taught this in my class, so I don't have any clue how to do this. It's okay. Yeah. So, if you want to see like how to graph things, I like to kind of line up the points in the same place. So here's what I'm gonna do. I'm gonna do like this. I'm gonna say this is 1. This is 2. And then let me like try to line it up. Sorry. Actually, I know what I'm gonna do. One sec. Let me just line it up like this. Here we go. 1, 2, 3. -1, -2, okay? Because what we're going to do then is we're going to look at what's happening here and, like, mark those as key points here. Good. Flippin' math tutor, what's up? Thanks for the heart, dude. I do think I saw a DM from you. Sorry, I haven't gotten to all my DMs. It's been super busy. But you have like a Halloween math thing. Let me do this. Any messages on TikTok? Okay. So, Andrew, exactly. When you're graphing the derivative, you need to look at what the slope is at different points. Okay. So here, from -2 slope. That's all it is. So. Right, exactly. My processor will start to melt soon. Yeah, soon. Yeah. Where things are not differentiable is wherever you have sharp points, which is where the derivative is changing really rapidly. So here, for instance, the derivative goes from being negative to positive like instantaneously. And it can't do that. So watch, from -2 to -1, you have a constant negative slope. That means from -2 to -1, you're going to have the value of your derivative is going to be negative, right? Below the, this is like x, and then this is, right? This is where it's like 0. But from -1 to 0, right? Now your slope is positive. And it looks like it's the same value of being positive. So I'm going to say from here that the slope is positive from 1 to 0. Does that make sense so far? Let me drop this down. Oh, fuck this up. Okay, cool. Okay, and then, yeah, here, also, look, the slope goes from being, like, really positive to, I guess it's also really positive. The slope may be continuous here. I don't know. How much do we trust that this slope is the exact same thing as this slope? But the point is undefined. And I don't think the derivative can be continuous if the function isn't continuous. At that point. But okay, let's look here. So at 0, you also have what looks to be a positive slope. So I'm going to put a positive value here, okay? But what's happening to the slope? The slope is going from being very steep to less steep to less steep to eventually being 0. And that looks like it happens around 1.5, okay? So on the graph of your derivative, I need the slope to go from being positive to eventually becoming 0 when x becomes 1.5. Ooh, Tidal Wave says there is no point at 0, 0, so it is differentiable. No, I think this is a point, though. I think this is solid. Right? And then this is open. I think it's a jump discontinuity, no? Yeah. Okay. And then as you go from being flat here to 3, now the derivative becomes more and more negative, okay? So that's going to have to like keep going down until eventually hit 0. But I think there's a hole here. I don't think you can take the derivative at a hole. Right? If there's no value for the function, oh, I see. Yeah, because this is a removable discontinuity, right? Do you also see this as like going to this? Yeah. Exactly. Okay. So there is no derivative here. Okay. Yes, do curves go to slants and slants just go to constant lines and then just go away? Correct. As long as they're quadratic. If you want to see why that is in terms of calculus, right? Right, so let's say like f of x is equal to x squared, right? Let's take a very basic graph, right? This is x squared, okay? Then f prime of x, right, would just be equal to 2x. And so notice what happens there, right? So, all right, let's do different colors, sorry for things. Sorry here. F prime of x is equal to 2. I'm going to graph it all on the same page. I know the axes isn't correct, but like whatever. So here, right, your slope is negative. Here, your slope is 0. Here, your slope is positive, okay? Notice how, right? This looks like a straight line. F of x is equal to 2x. Right, but this is f prime of x, sorry, is equal to 2x. This is f of x is equal to x squared. And we did that, right, because if you take the derivative using the power rule, drop the 2 down, move the power down by 1. Sorry, tidal wave says it's still differentiable since there is a limit from the right side and the point is defined at 0, 0. But wait. At 0, it doesn't approach the same point, though, no? Yeah, the limit as x approaches 0 from the right is 0. The limit as it approaches x from the left is 3. So that's not the definition of the derivative. Yeah. That's the definition of a limit existing. Yeah, you think you get it now? Okay, cool. But then here's the cool thing. Watch this. So then f double prime of x, which is the second derivative, again, just drop the power, remove it by 1. That's just equal to 2, right? And that's just going to be equal to this. This is f double prime of x is equal to 2. And then finally, if you got down to like f triple prime of x, that would be equal to 0. And that's why you eventually just get a flat line, right? The slope of a flat line is just 0. And then all the derivatives after this just kind of keep becoming 0. This concept comes up a lot when you eventually start doing what's called like L'Hopital's rule. You end up just like keep taking derivatives until you eventually like kill one off, and then you have one like surviving. Yeah, you get it? Cool. All right, awesome. Glad it makes sense to you. Nice. Nice. Good question from Andrew. Let's mark that as done. Very good teacher, man. I appreciate that, dude. Thank you, dog. Appreciate that, big dog. Let me see if I can I read my TikTok DMs? Sorry. Let me see if I can do that. Messages. Yeah. Look at all these message requests I have. Okay, but I have yours flipping. Flipping Math says, I have a math challenge for October. Would you be interested in checking out? Yes, I love math challenges. Where's your math challenge? Oh, here it is. Ooh. Okay, wait 1 sec. What is this? I want to check this shit out. What? Let's go check out the math challenge. Wait, I just copied it. Excuse me. I like the music. Oh, no. Where's... Is it your birthday, though, too? 1 sec. I'm really trying to get this link. No. Dude, how do I grab the link? Is it on your link tree? That would help me out, too. Let me see. I don't know why my thing is not working. I'm trying to grab it. There we go. Cool. Got it. We got the math challenge. Yeah, for sure. Oh, no. Error. Uh-oh. Here. Maybe it's on here? No. Well, flip the math. Send me a DM when the link works, and I'll totally do your math challenge. That sounds cool. Okay. Name YT. We're gonna talk about periods, it looks like. Cool. Oh, one-sided and two-sided derivatives. Yeah, no, that's totally cool. Yeah. All good, brother. Yeah, make sure like, subscribe, follow, turn on notifications, all that stuff. If you ever have questions, I am here. You can get help. Gold's still on. My bedtime. Dude, okay, you want to know why I'm still on? It's because YouTube has... I don't know, if any of you guys want to be YouTubers, it's actually quite difficult. They have such a requirement for getting monetization, and it's this. This requirement here is like the bane of my existence. The amount of like public watch hours you have to get. And luckily these live streams have been doing pretty well since the school year started. So I've started doing them more because now I can get like at least 70 or 80 watch hours per day. So multiply that by, I don't know, like a week or two. and we'll finally be like full YouTube partner. And then I will continue to stream, so don't worry. Okay, let's try to do this. Let f be a sinusoidal function. The graph of f of x is given in the xy plane. What is the period of f? Cool. So period, yt, is the distance between two peaks or between two troughs. It is not the distance between two zeros. That is not true. You have to very specifically go from here to here or from here to here. Okay. So let's look at, for instance, this distance, okay? Gonna kick all Twitchers to the curb. No, I love Twitch. I've explained Femvox. I will always continue to stream on Twitch because the community there is stronger. People tend to watch for longer. Whereas, like, I don't know, TikTok for sure, people come in and out and then they just bounce. YouTube, they stick around for a little bit, but Twitch is the most that people like stick for. Okay, so here, period is equal to 4. I think that's pretty simple, yeah? Yeah, just look at the distance between two peaks. You're good. I did do your question name. Did this make sense to you? Yippee? Yeah? Well, yippee doesn't make sense. Do you need me to explain it more? Anything to the power 0 equals 1? I can show that real quick. That's really easy. Okay. What's x to the 4th over x squared? Right? Let's think about that. That's x times x times x times x over x times x. A couple of these cancel, no? Cancel. And you're left with x squared. Did you notice how that rule was x to the 4 minus 2? Ooh. Well, what happens if I do x to the 4th over x to the 4th? That's x to the 4 minus 4, which is equal to x to the 0. But let's show what that was, right? So that was x times x times x times x all over x times x times x times x. Cancel. That's just equal to 1. This is also equal to 1. So this is why x to the 0 equals 1. Does that make more sense? The only difference is 0 to the 0 does not equal 1. That's not true. If everything cancels out, wouldn't it be 0? No. They cancel out to 1, right? Think about like 5 over 5, right? These cancel, but that just becomes 1. If I had, I don't know, like 5 times 4 times 3 over 3 times 4 times 5, right? You could cancel this with this, this with this, this with this. You would get 1. You could also multiply it out. That would be 60 over 60, which is also equal to 1. 5 minus 5 equals 0. Don't do that, Jeff. No.
Oh no.
Oh no, dude. Okay. Ooh, family solutions. Ooh, did someone hit me with DiffyQ today? Damn. Okay. All right. So here, let's clear that one. Good job. Name at UT. At YT. Bum, 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 bum. Is that unjust? Yes. 0 over 0 is undefined, Hunter. 100%. Don't do it. Don't divide by 0.
Oh no.
No. Yeah, I definitely do undergrad math and physics. I mean, this is, I don't know, this looks kind of undergrad-y. Maybe. This is, man, what is this called? There's a name for this type of solution. Is this like integrating factors or something? It's like when you have h dx minus m dy is equal to 0. What is this? I know this is something. I gotta like show that it's conservative, I think. I have to show that like dh dy equals dm dx. Yeah, it's exact. Oh, okay, that's what it is. What do you do when you get to too many questions in the queue to get through in the stream? It's a good question, Fembox. I think we will reach that problem when we get to it, and I will welcome that problem. I think what I end up doing is I start either implementing a random kind of like number generator for like which questions I do, or I start closing off certain days to certain subjects. So right now, I mean, we've done chemistry, we've done statistics, we've done physics, we've done math, but maybe I make it so like this stream is physics, this stream is math, this stream is chemistry. I mean, eventually I hopefully just have another one of me, because yeah, I don't scale. Okay, but yeah, I think this is an exact equation. So if we were to look at this, that would end up being 6y, right? And then if I do this, well, that ends up equaling like minus 2x. So wait, is that not exact then? I forget how this works. Let's look it up real quick. Paul's math. I love Paul. Paul's math notes are great. Let's go watch Paul. This is it. Yep, here we go. This is what I want. Well, I guess AI gave me this, but you're supposed to make it exact by an integrating factor. Oh, fuck. Okay. It's homogeneous, right? What does that mean if it's homogeneous? Can I separate? Is it separable then? Express it as a function of y over x. Okay, let's try and do that. I mean, I kind of like that better than integrating factors. Okay, so what? 2xy dy is equal to 3x squared plus y squared dx. And then, let's try to get dy dx, right? So let me move this, let me move this. So dy over dx is equal to 3 times 3x squared plus y squared over 2xy. Yeah? Could you help me with my real analysis course? I've only taken up to complex analysis. If you want, right, if you want help with like real analysis, I'm not the only person that does this. I always tell people, if you go to that website that you use to submit questions, that actualdiscord.com/submit, there's a calendar on there, and the streaming calendar shows when a really good friend of ours, Zach, E2IPi, streams, and he has like a PhD in math. I have a PhD in physics, so my math knowledge caps out at a certain level. Zach goes above and beyond. He could probably help you out with real analysis, and he has a stream on Saturday morning if you want some help. Okay. Wait. So what do I do? What do I do next here, Fem? Express it as a function of y over x. Okay. I think I see what you're saying. Okay. So let's expand. Okay, sure. 9x squared over 2xy. Yeah, I can definitely help with multiplying numbers. I would welcome that. I mean, this is kind of fun though. Okay. So then this is equal to 9/2 x over y plus 3/2 y over x. Yeah? He has a YouTube but no videos. Who has a YouTube but no videos? Zach? This is, I believe this is differential equations, is what this is. Laplace both sides for good measure. Okay, he says u equals y over x. Let's just try that. Okay, u is equal to y over x. Okay. So then, okay, so then y is equal to ux. So what? Dy dx is equal to u? Oh, plus du dx, right? Because you still have to know. We still don't know if u depends. Well, u definitely depends on x. It's like circular logic, actually. Y equals ux. Okay, cool. I think I'm getting this. Okay, wait. So u plus du over dx is equal to 9/2. X over y is now 1 over u. And then plus, actually, sorry. 9/2, 1 over u, plus 3/2 u. Yeah? Undergrad E&M, Griffiths. Griffiths is great for E&M undergrad, yeah. Subtract u from both sides? Oh, yeah, I guess you can. Nice. Okay, wait. So du dx is equal to 9/2 over u, and then 3/2 minus u is 1/2 u, yeah? Oh, fucking sick. Okay, wait. So du dx is equal to 1/2 9 over u plus u. And then, do I just integrate this? Right? Wait, where's my x, though? Isn't there supposed to be an x around here somewhere? Oh, sorry. This is a chain rule. Sorry, my bad. I forgot about this. Sorry. This is... What are your office hours? Website, calendar, schedule. If you go to... Here, go to streaming schedule. This has the hours that we do everything. So, I will be on tomorrow. I'm very far extended today. So, I don't usually stream this late, but I see a bunch of people. Yeah, it works, right? Okay, wait. Yeah, okay, wait. This is a chain rule, right? So, it's derivative of the first times the second. So, that's du dx times x times derivative of the second, which is 1, times the first. Okay, cool. So, then this is x du dx. Oh, I think I see how this works. Oh, you tricky bitch. Oh, this is so cool. So, now I'm going to move this over, move this over. And so, we get... 2 du 1 over 9 over u plus u, right? Is equal to dx over x. Yeah, and a pinned comment. Yeah, I should. I don't... Can I do that on YouTube? Is there a way to do that? Are there pinned comments? I don't know how to do that. Whatever. I'll figure it out at some point. Cool. This is ln of x, no? Right? Yeah. And then here, I don't like this in the denominator. I'm going to multiply top and bottom by u. So that's going to get me u over 9 plus u squared. Right? Thank you for the follow. Angelesp. I do appreciate your follow. That's really nice of you. Okay. Ooh. This is this is u substitution on u. I don't want to do that. Okay, whatever. Ln of x, yeah, plus c, and then this is there's okay. I can't do. I've been streaming for 3.5 hours, so I can't do u sub in my head, especially when one of the variables is u. Just boggling my brain right now. Okay. I'm going to say 9 plus u squared is equal to v. dv is equal to 2u du. Okay. So then du. Okay. Okay, then there's 2u du. Okay, sick. Love that. Okay. We're big fans of that. So, okay, cool. So then this is the integral of dv over v. Oh, it's just ln of v. Oh, that's so cool. Beautiful, right? Okay, so that's just ln of v, but v is that, so it's ln of 9 plus u squared is equal to the ln of x plus c. Okay, we're getting closer. But then u was y over x, so ln of 9 plus y squared over x squared is equal to the ln of x plus c. Okay, e to the, right? So 9 plus y squared over x squared is equal to x plus e to the c, but e to the c is just another constant. I don't care about that, right? Or no, it's a multiplicative constant. Sorry. I do e to the whole thing. So that's times e to the c. So that's times c. Multiply through 9 plus y squared is equal to x to the third c. And I think this is it. Nice. Cool. That's a very cool question. Oh, man. Thank you, Ed.
Well done! Well done!
This was the question. That's right. Why do you have a constant after the function? Because there is a constant. Because the family has a constant. Okay. 2 more questions. And then I'm probably going to call it at this point. Because once I need to eat dinner. Also, TikTok is mad at me for streaming this long. It's like, solve the CAPTCHA. Okay, let's see. Oh, x to the third c times... Yeah, no, I agree, Sebastian. I agree. I'm over the style points at this point. Okay. Oh, we did this one. YT submitted again. Cool. And then Andrew has more induction, but... Okay. He said he wanted the third one, I think. If he's still here. Andrew, you still here? I know he might have left. And then in that case, I probably want to save this question for him. But he had something else with that. Yeah. What's your name, sir? Dr. G? Dr. Gold? That's my name. If you want my government name, you can find it easy enough. And then let's mark these as done. Nice. Okay, cool. Yeah. All right. I think Andrew left, so I'm gonna wait for tomorrow's stream to do this one. Okay. So for everyone watching me on YouTube, because I'm gonna end the stream pretty soon here. He's the top G. Appreciate that. We do have a website that makes it very easy for you to figure out when we're streaming, when you can get help, and how to submit your own questions. So that website there is actualdiscord.com/submit. Go there. You can type your username in. You can drop in a question. I'll do it. We've been streaming for 3.5 hours, so I'm going to end this stream. But on the next stream, if you want to figure out when that is, go here to streaming schedule, and that'll show you when we stream. So tomorrow's stream will be at 4 o'clock Pacific. I don't know if I can run it as late as I did tonight, but We also then, I have a interview with Tiny Toxic Tofu on Friday. I'm going to talk about my PhD, what I think about education and science. And then Zach has a stream on Saturday. So, yeah, cool. Okay, that being said, let's close out the stream. All right, thank you everyone for coming to Actual Education Office Hours today. Really appreciate all the questions. We went through everything. We hit a record time, I think, on the stream, 3 hours and 40 minutes. Thanks for being a part of that. You guys, always the goats. All right, so our next stream will be tomorrow. Again, if you're just finding us now, please like, subscribe, follow, turn on notifications, all that good stuff. It helps the algorithm pump us to the front, and then more students see how they can get help with math and science instead of feet picks and, I don't know, like thirst traps. So, help us out. It costs nothing to like and follow. Thank you, Femvox. Yeah, good night. We're going to bed. If you're watching us on Twitch, which, again, if you want to watch us on Twitch, again, website, there's a Twitch link. It's a little bit easier to watch the stream because it's a horizontal format. YouTube just really prefers vertical for exposure, so that's why we stream on YouTube in vertical. I stream horizontal, I'll get 0 views. I stream on vertical all day. So let's see. We're gonna go. Let's go raid Eric. Yes, I love Eric. Eric's great. I haven't seen Eric in forever. He has a beard now. This is awesome. Okay, cool. Go say hi to Ian Stuckey. He's a really good friend of ours. I haven't